All right. I'm back. Oh, how's it going? I haven't gotten anything done. Actually, yesterday I did uploads. Uploads and I think a couple other things. I was mainly reading about getting a Twitch API into Node-RED. There's one particular one that I want to use, but I have to like protect my Node-RED from the outside world, I guess. I don't know if I really need to do that though. Are people going to be able to identify my Node-RED and get into it? I don't really think so. It's not like you guys know my IP address here. I could probably slip up and accidentally share my IP. Generally though, we're pretty safe. Not to mention the fact, well, because yeah, we get to the outside world all the time here through non-sterile means. So I don't know. Let me see, where are we? Okay, we're shift registers are what went up on the channel last, on the VOD channel. My bitrate is abysmal. Oh no, it's back up, never mind. And I've got viewers, a couple. Cool. Yeah, we're back to doing circuit work because I didn't get anything done. I don't know, I kind of want to finish that filter, and at the same time, I have some ideas about what I can do with the, what do you call it? With the circuit for the oscilloscope, the op-amp input circuit. Might be able to just replicate what Hajiwo's circuit is. I would at least like to do that just to see what it does. Just to see what it do. And then we can try to make our own circuit that does the same thing. Might have to go and reference circuit books. I have a circuit book upstairs that I need to... I don't know how to refurbish a book that's been on a shelf where the book is collapsed, because it's so heavy. The pages are so heavy for the book that it's become like a wave because it kind of collapsed in on itself. It didn't have surrounding books to smush it. And it kind of did an oopsie. That's upstairs in my bedroom, so I need to go get that at some point and put a 16-pound weight on it. I got a 16-pound weight that I use for just like little bicep exercises that I need to get back into. And then I'll put that on it for like a month, and hopefully that fixes it. Where are we? Oh, you guys are way over there. Come on back. I do want to work on this RC car more too. I've been trying to get ahead of all of the uploads that have been going on. I mean, this thing is like, I'm excited to see how this thing does outside now that I've got a bespoke front spoiler, and then the rear has a little bit more upwards curvature to try to push it down when it gets to high speeds. Because it actually does a lot. It actually does quite a bit. But I need to finish wiring this up, and I wanted to go with sockets, but I just don't have the parts. I don't have those sockets. Wait a minute, do I have the sockets over here? Over here? I have some 3 pins, but they're all right angles. No, these are various things that I need to get back into the swing. There's a couple ASICs and a couple transistors and things that might fix other synthesizer things. So I need days that I can focus. Oh wait, maybe I can use these. Oh no, these are too big. These are the PT 2.0 sockets. Good to know all these sockets by name. All these different plugs. JST. What are the other one? Hyros has a couple different series that are used in stuff. These are called PT 2.0. They're the little 3-pin ones that have a slot down the center, and they're actually the ones that interface with the batteries that I bought for some reason. Some drones use them, I guess. And then I need to fit a capacitor in here. I need a big capacitor or a board with a bunch of little capacitors. No, I'm just happy to see you. Actually, is what it is. I'm sorry, it's a little embarrassing. You know, if you flex your legs, you can deal with that. You got to flex your legs, and then all the blood is needed for muscle instead of for, yeah. But you know, I'm just happy. Pop out chat. There we go. There's YouTube chat. Now that I'm done making boner jokes. Everybody's loaded up. How's it going, Poopsie Doodle? I'm talking RC car just because it's fun. My motivation is for fun. Oh, we should turn this on. This is going to take forever. I want to see what that Hajiwo circuit does. I want to build that in some form, and then we can compare the output from ours and try to replicate it. And I've got a couple of weird ideas that might actually do something. I think the PT2, yeah, it's way too big. Way too big. All right, so these are for a different collection. I could have used those. I ordered a whole kit of PT connectors. I didn't know I had those two. That would have solved my issue. I bought a whole kit of connectors so I could make this plug. Darn. Let me get that surface mount connector bin out and I'll see what I've got. You know, it's like I might have ordered connectors. I just don't know it. There's actually another thing of connectors all the way at the bottom of this drawer. I should get that out. I'll get this box out of here that's going to dox me. The dox boxes that have my address on them. The boxes. Another thing that I've been meaning to do is plug in my the keyway adapter to the Ethernet wire that I have, the new Ethernet wire. Plug in the keyway adapter and then pull it through all this stuff behind all the desks and stuff so that I can finally plug into my router and actually get good speeds from my internet at my computer. Right now, the internet at my computer is where it's always been, which is something like 80, 80, 80. 80 up, 80 down, 80 across, 80 HD. There's a bunch of connectors in here, but I don't think any 3-pin ones. It would be nice to convert this whole thing to connectors and make like just like a wiring harness for it, but I don't think I'm going to be able to do that. That's like a quick job for us to do. I mean, we could even do that before stream starts if I'm feeling particularly industrious. Man, nobody's around today. Nobody's around. Oh, I saw a Twitter post where somebody meticulously 3D modeled one of these. It wasn't this version, it was a through-hole version of a coin cell holder. I thought I related to that very closely. It's like, I don't have ADHD, but I did just meticulously model, painstakingly model this coin cell socket. It's like, yeah, I've been there. You're just like, your whole, every cell in your body needs to have a fancy 3D model for a thing. You can't stop it. This is a surface mount 3-pin? No, that's a through-hole 3-pin. That one might work. I'll need to plug something into it to solder it, though. I need to get the solder off of it. There's big blobs of solder on it. I don't have a lot of 3 pins in here. Really, I need one more. Maybe I could use a surface mount for the radio. This is RimWorld music that we are listening to. Yeah, I don't know. The DOTS Micro stuff really wants you to just go straight wire to board. And I guess I'll do socket, like crimp connector to board, and that'll solder up nice. Well, yeah, exactly. Let's get distracted by random stuff. That's exactly what's happening to me right now. I'm getting completely distracted by the RC car stuff. Totally and completely distracted. Let's just check this out real quick. I really want to get some of this modular stuff done. This was not supposed to take this much time. We just got, you know, there's been a couple weird things. Hey, Commander Big M, you didn't have to do that, but you did for 6 months. Thank you, Commander Big M. Thank you. I appreciate you subbing. Let's see. Let's get this out of here. All right. We're just looking at stuff. Oh, this needs calibration. Hold on. Setup. Micro procedure. Bonk. Oh, look, it suddenly looks good. That's a little better. Been a while, I felt like a freeloader. No. There's no need to feel like that. You know, my motivations for doing this stream are not monetary. Obviously, I don't make a shit ton of money. It would be nice if I could support myself off of this, but yeah, mostly I'm just a pimple on society, doing my own little thing and trying to teach you guys stuff that's fun. Yeah, those are surface mount 4 pins. Don't need that. DF13 2-pin plug. DF13 2-pin socket. We don't need 2 pins because I need to do power distribution too, and it's not like I have a 1-pin. DF13 5-pin would be the one that that would fit on the radio. Let's see. So we got our electronics stack here. It looked way bigger in CAD. I would love to use connectors on these things because then I could unplug the radio and plug it back in. Now, these are the right pin pitch, right? Or at least manageable. Hey, no worries at all. You do not need any kind of no voices in the back of the head here. We're just vibing. You may feel compelled to contribute, and that would be fun, but you don't have to. Sure. That's not really going to fit, is it? 4 pins, and then the 5th pin for the channel 1. I think that's... Is that... It's like channel 1, 2, 3 is on the left there, and then that's channel 4, which I could hook up to a light if I really wanted to, but I can't really get to... Like, if I could center that and have it be under, that would be much better, but I don't think I can. Pinout on this thing is weird. And then I think those are... Well, we'll look at the pinout in a minute. I don't think it's a repeat pinout, because there's 8 channels on this thing. This thing has 8 channels, believe it or not. So we got 3 channels here, or sorry, 1 channel here in power. Power in channel 1, and then we have on this side 5, 6, 7, 8, and on the other side it's 1, 2, 3, 4. So over here, channel 1, 2, 3, 4. And I want this LED to be facing upwards, otherwise you don't get the statuses. Oh, and let's look up. The DOS Micro 8-channel, and we'll just pin out. It's a really good radio. It's very, very tiny. I wouldn't have imagined back in the day that they would be so small and have such capabilities. Look at that little guy. Look at that little guy. So, yeah, we're going to do circuit work today because it's quick and it's fun and we can see everything happening. Ground VCC channel 1, and then we've got channel 1, 2, 3, 4, and I use channels 1, 2, and 3. 3 is the one that controls the gyro, so I can turn that on and off. What's the chip? Well, that's the DOS Micro 8-channel Fly Sky receiver, which is a very nice little receiver. It's quite good. The chip on it, God, I don't know, what is that? 14K22 V1.0 001 A44. It's some microcontroller, man. I don't know. Actually, there's a chip on both sides. One of them is a radio transceiver, and the other one is a micro. So yeah, I'm just looking to see if I can get some kind of a connector on here. So if 5-pin is probably a little bit ambitious. 4-pin is really what I need. 5-pin SOIC. Where's the 5-pin socket? 5-pin plug. And then DF13 3-pin. That's the plug. It's later. I don't have a 3-pin right angle. I have a JST 2-pin right angle. And then the miscellaneous pin only had one of these. If I could find another one of these, I'd be in good shape. And then, oh, I have 4-pin though. Actually, 4-pin. Well, the SMD. I don't think this isn't going to fit. Is the problem? Like if I put this huge plug on this thing, it'll solder in, but it won't fit in the enclosure. I'd have to alter things a little bit. So wires directly to this thing is probably the way to go. If I do that, I might be able to anchor this pin on the, which one is that? That's VCC. Never mind. I don't want to anchor that there. It'd be pretty fragile too, because these are just pads on the board, and if anything bumps into that connector, I'd be in trouble. Yeah, here's a regular 4-pin. I think the regular 4-pin, not the surface mount 4-pin, would be the way to go. Did I just put the 3-pin in there? I did. Get you back. This one, no, this one. This one goes back. Yeah, this would be the way to go if I designed for it originally. Put that there, and I've got all 4 of my channels, and then put a 2-pin on the... I mean, I could still design for this. I think I've got the Hyros in my files. I could do that, and then the 2-pin socket. I don't know if I have a right angle 2-pin, that would be better, but I could do this. What are those pads? They tell me what those pads are? They don't. What are these two little goobers doing behind the power? Looks like there's an LED. No, that's over here. Okay, so what's the one on top? I don't see what they are. Are they just repeat ground and power? If they are, then this thing can go back a little bit and just sit like that. But if they're not, I gotta be careful about shorting out to them. Yeah, I guess that might be the way to go though, because then I have a wiring harness for the whole thing. Let me check what these 2 pins are. I need a multimeter for that. Everything is so small. Jumpers to perf board with a dab of hot glue. The real move, if I wanted to make it as light as possible and as protected, it would probably be wired directly to board and then a little dabble of UV epoxy so that the wire is supported up to its jacket. So from this pin, this is VCC. I need the microscope. I can't see what I'm doing. RimWorld is such cozy music. I fast-forwarded halfway through just for this so that we'd have a slightly varied intro. I'm having trouble finding intro music because I'm uncreative. I'm uncreative. Usually game music is a good way to go, but I haven't played anything with a particularly notable soundtrack lately. Fallout doesn't really, I don't really know if Fallout counts. Yeah, RimWorld's so nice. RimWorld. It's just cozy. I don't want to listen to that song. That song, every time I put the big tip on the soldering iron, that song is just welded into my brain. 1/2 ohm. Okay, so that is connected to VCC. What about you? 1/4 ohm. Yeah. So those are the same thing. So I can actually bleed over. Wait a minute. I got 1/2 ohm for a second there. I think that might have been a capacitor. 1.3 ohms. And then over here. Yeah, I'm charging a capacitor. Okay. So yeah, these two are power and ground. The two behind the power and ground. Which is nice because it's very difficult. Oh yeah, does Fallout have a ton of copyrights? This is the kind of world we live in. You can sign up for a service and not have to worry about copyrights. But so what's that going to take? That's going to take spreading the electronics out more because that's not going to fit. This goes in like this. That or I angle it downwards or something. But if I got the 2 plugs sitting over there, then this isn't going to really fit in my electronics thing. This is like loose. So maybe I put the Bosch on the connector. Maybe I just solder wires in. Because it all stays in this little cubby hole. And then what I'm going to do is once I get them all connected, I'm going to put just a dollop of UV epoxy on the edges. Just a dollop here, a dollop there, there, and there. And then this one needs to come out because there's 2 screws under it in order to remove the cross beam. Those 2 screws are rather important. We'll have a plug going to that. And then this thing doesn't unplug, but it can be removed. So yeah, I guess that's the way it'll be. Which is a shame, because if I had plugs on everything, it would at least be a little bit more modular. Not that I ever changed the configuration, but if stuff breaks, it's good to have backups. Especially with RC cars. You know, you can run into all kinds of weird little problems, but I could have soldered up a pair of each device. I only have one of these motor controllers, though, and I would love... I don't have the time. If I had the time, I would love to reprogram this... What is it? What was it called again? Well, these are called Talon Skystar. They're 40 amp 3-phase controllers. It's got a nice little heatsink on the top. They're for drones, which means you don't get reverse. But if I could somehow reprogram that UI program, it's like a Google extension that you can actually program this thing with and give it all the features of this, because it's just FETs, right? It's just FETs in a normal 3-phase configuration. this is capable of going in reverse. So if I had the braking functions and the reverse functions that this thing has, I could then program it with a UI, which would be really cool. And it takes up a whole hell of a lot less space. This thing is incredibly compact, and it was only 15 bucks for four of them. But I don't have the time to get through the code. Wish I had time to get through the code and learn how it's working and stuff. Because that would be super cool. It'd be super compact. All on top of this thing. Although I could put it out on the outside of the car like this. That'd be kind of cool. This is Twitch, the platform with a 24/7 Mythbusters stream. Yeah. I don't know what to tell you. It's also got a big LED on it, too. I really wish I could use these. It would take a significant amount of programming, though, for me to get it there. To get it up to speed. Get it? Because it's a RC car. It goes fast is what I'm trying. It's the speed is like a velocity joke. What's this one? This is 4-pin. 4-pin. This one. He got it. He got it. We got there. We got there. All right, let's put this stuff away. I don't have any specialty sockets that could make or break my day for this thing. What was this bin? A bunch of weird stuff. That one's a crazy. That was for the servo. I wish I had a little bit more agency over being able to make a big mess here. Because if I could make a big mess, we could do some fun stuff. I could get back into some crazy projects, but we keep it kind of low-key here because I don't want to create a ruckus. If I had a garage, I'd probably be doing weirder stuff. We do smoking streams, right? I actually do need to... I set up the ultrasonic cleaner next to the utility sink. I finally measured and found a little shelf that would fit there. So now I've got the cleaning station right next to the sink. So that'll be nice. I'll be able to actually clean stuff off. And the first thing that I need to clean off in the ultrasonic bath is the cold smoker that sat outside. I need to attach the cold smoker to the hot smoker, but the cold smoker is disgusting. There's all this aluminum oxide all over everything, and then charred gratings and stuff. Charred rusted metal gratings. So I need to do a little bit of either, I mean, in the end, it'll probably, hey, Niano, how's it going? In the end, it'll probably be like wire wheel Dremel kind of stuff, or wire wheel angle iron, angle grinder kind of stuff. It's time for more coffee. I had 2 cups of coffee today, and I feel nothing. I feel nothing. Coffee does nothing for me these days. Nothing. Although I haven't had energy drinks in a while. Usually I get real babbly when I get a bunch of energy drinks. There's a kid that wants their Mario Kart pack. Finish it. Oh, I know, Dat Dolphin. I know. How you doing? How you been? I've been seeing your comments on a lot of older streams because I've been uploading the VODs, and you guys are all over the VODs. Dat Dolphin's been here for a long time. Well, I mean, they left and came back, but this is the part from the Mario Kart home circuit that I need to redesign, and I need to do just the border, and then I need to make something that'll hold the motor and that longer axle, or another axle. I don't know how I'm going to be able to do that, because the axle on that thing is so weirdly made, and I don't know where to source parts like that. It's titanium. Like, where am I going to get something like that? But if I can redo this axle to have one of these motors in it, I can make the Mario Kart home circuit go ridiculously fast, and maybe I can do something cool, like make it a meme. The original one does not. The original one just has this little pinion gear here. It's got one extra gear, and then it's got a simple DC motor, and then another gear with a hex center in order to make this axle. So hex bar is really easy to find, but what I want to do is put in like a nice one. Hey, what's up, Gonad? Man, we got all the good people are here today. Everybody else sucks. You guys are awesome. Just take that to heart, okay? John to heart. Let him quote Shakespeare. John DeHart is one of these people from that like Red Letter Media discovered, made a movie that was a complete vanity project. I cannot stay. I am not here. Woe beest to all of us for the departure of Nyano Cat. I wish I had acted on this thing faster, because then I could have gotten it in Djibouti Show's hands, and maybe through doing that I could have had a few more viewers. I could have actually done work to get viewers. How's that? That's a weird concept. One thing that I want to do with this axle, aside from modifying the Mario Kart, is make a pan car. And the pan car, I would like to utilize this circuit board. The circuit board that we built that does not quite work very well. Yeah, we've got, Short Lurker and I went through painstaking efforts to model this in Fusion 360. So the problem is with the Mario Kart is that it's very wide. And so I sourced a little standoff, but I don't like extending this in one direction. It'd be nice if I could extend it in both directions. The only problem is this thing drives the other side of the axle through this plate right here and two little cuts. So I'd have to make something that spun the wheel. We're racing frying pans. What a time to be alive. Actually, you guys over there in England land have teapot races where you buy these cheapo teapots and modify them with like silly RC car stuff. And it's a very whimsical little racing circuit. I would love to participate in that. Not live. No, I'm not. This is pre-recorded. This is actually pre-recorded. I hate to break that to you. Yeah, this little axle's really nice. Here, take a closer look. Cheese race? Dude, they have all the cool, like, whimsical stuff over there, man. They really do. I should just move. I should just move. Mainly become an insulin refugee, primarily. Yeah, so this is like a titanium axle. It's really nice. I don't know how to extend or you know, do anything else. Yeah, the cheese roll run is deadly. I thought you meant like they were making cheese like RC cars. So that's more my speed. Why is it saying stream starts soon? Because I'm not here. I'm not actually here. This is pre-recorded. That's why it says that. This is a pre-recorded message that will eventually go live when the time comes. There's a timer. This is the pre-stream. This isn't the project we're working on today. This is obviously not a modular synthesizer, right? So we just get distracted, we talk about whatever, and then when I gather enough people, I'll then start the stream and talk about what the subject is, and that'll reduce the number of people who drop in and go, what are we doing? Because I get that almost constant. Some streams are so complicated, some things that I'm doing here so complicated that it takes me 20 minutes to explain it. And people will drop in and like my whole stream is me explaining the project. It's crazy. Yeah, pre-recorded chat comments too. They actually submitted these ahead of time. That's what the Discord's for. Make a comment for that. Well, yeah. That's too much like work. Sydney cake for 20 minutes before I start. That's like, so other streamers will put up like start soon. And it's like, dude, you're just doing that through OBS. You might as well sit here and just like chew the fat with your fans, which I love doing. Of course, I do that during stream too, so it doesn't really, this is a very loose axle. I don't know what's going on. Like, I'm having trouble visualizing this thing actually moving forwards. But I would like to get this thing into actually moving. Yeah, the only account that's legitimate is mine, and I just have a bunch of sock puppets that are talking to me right now. So it drives the wheel through this thing, right? And then this is freewheeling. So this whole axle is dedicated to one wheel. And I've put a little extension on the end here. And then over here, we have the thing that interfaces with the other wheel. So the problem is, this, I'd have to lock down with some pretty serious Loctite in order for it to not disassemble itself during shenanigans. In addition to that, I'm only extending one side. And so this gear is going to be all the way on the outside of the car. Now, if I didn't extend the wheelbase and I used a normal Mini Z wheelbase, I could get rid of the extension thing. We could make a motor pod for this, and then we could figure out how the servo is going to go up and make a steering linkage that screws in there. And so then I'd have a motor pod pan car made out of an old circuit board, or two. I'm going to take both of these and try to make them into like a full chassis. A full Mini Z chassis. It'd be a little wide for a Mini Z chassis though. One of these is good to make like a weird little RC car. I could probably put suspension stuff on the outside so that it's got weird suspension on it. Yeah. Yeah, how do they do this for $20? Actually, I think this one was like $30 to $40. But how do they do that, like manufacturing? I mean, these are ball bearings inside of there, and ball bearings are fairly common industrial parts. The plastic gear bevel, I guess you have to get that plastic gear manufactured. This stuff is common. There's similar parts between this kit and this. But the Mario Kart home circuit is completely bespoke. They had the power of Nintendo and anime on their side, and they made a completely bespoke, you know, plastic shell for Mario. I would like to put the Mini Z stuff in here. Fat chance I get the camera working. I don't know if I could do that. But if I get all the Mini Z stuff in here and take over the servo and then get a motor pod, I need to build, this is the part that I need to build. I don't need to build anything else, just that part in there. And then I could have one of these, where's the motor? Let me go get a motor, hold on. I got a bunch of these things. And the one that I would put in, obviously, is the one that's way too fast. Way, way too fast, so that I could get a clip of the Mario Kart home circuit going 1 billion miles an hour down my street. I really want to get a capture of this thing going like super fast. Well, not really, because we don't know what the pinout of this thing is doing. Now, the Mario Kart home circuit is interesting. We can talk about this for a minute before stream. Oh yeah, the hovercrafts are out in droves today. The neighborhood got so overgrown that I think the grass started to seed and it would actually repair itself. And I was super excited about that, but everybody else hates it. Were they discontinued? Why? I've still got a full one in the package as a backup. And then the one clip that everybody links me to for the Mario Kart home circuit is the one with the Luigi kart racing around, and there's a giant purple dildo in the background. This stream's not for kids. I should probably put up some content warnings. Less content warnings mean more viewers. Let's hope that one just slides under the Twitch. There's a lot known about these too, like the entire control protocol is apparently known. But this board right here is the main circuit board for the Mario Kart home circuit, and this is just a Raspberry Pi. This is a Raspberry Pi. If you look at the development stuff for the Mario Kart home circuit, you can see their prototype was just a WL Toys Mini Z kit. The WL Toys like 989, and they put a camera on the back of it. They basically just zip tied a Raspberry Pi W, I think, 0W to it, and then they put a camera, a Pi camera. So I don't know if the pinout is going to be Pi camera or what, but it would be. I have actually a. I don't know if it's the same chip, actually, to be honest. I didn't know. What do we have here? This is $100 that I had to eat out of stream expenses in order to. Well, it's $200 because I bought two. I was really excited about collaborating with Kavuti Show on this, and I probably should have held back a little bit. RTD 1195 PB. That I think is an AV chip. So whatever the RTD 1195 PB is, that's an ST Micro. That's, I believe, for USB. Can't be a Pi that can't process video that fast. They've got all the protocols up, and they were originally using a Pi. I don't know if they swapped. I mean, obviously they swapped to something else because these aren't Raspberry Pi chips. That's RF right there. They set up maybe some kind of a pipeline. I mean, they didn't need sound. They only needed video. So I wonder what's going on inside of this little guy right here. I don't know what speed that is. It's probably a bespoke controller that's like super, super nice. Look at those little pads up there. It's like a bunch of little resistor connections that weren't never made. Huh. That's, I think, the charging controller. Yeah, it is a Realtek. That's what that logo is. RC. Crab. I don't know. You guys can Google this stuff, though, because I don't know nothing about nothing. I don't know nothing about nothing. we were going to try to make a go-between from this controller to the actual, to like an actual servo, because what they do is they break the servo down into just a potentiometer and a motor, right? A simple geared motor and a potentiometer. And I was going to try to have that go to like our own controller that would then control a servo, and then have the motor signal plus minus, and then the range of voltages, like whatever PWM signals they're sending to the actual motor itself, because all that hardware is on here, and then have the have the controller do, like, you know, go to an RC signal, make it into a servo signal that'll control a 3-phase motor controller. So it'd be like Mario Kart would be screaming fast. I don't know if there are checks and balances inside of this thing where it wants a specific velocity for what the control signal is. That might be the case. So if you put a big mean motor on it, it won't actually do anything. But I want to put a big mean motor on it just because this is a funny RC car shell. It's an expensive one, but it's funny. But yeah, the problem with this axle is it would have to sit on the outside of the enclosure. So I would have to have the motor stick out to it, which, you know, calls for a full redesign of this thing, because all this stuff has to fit here. It's possible I could just lop this off and then lop all this stuff off and try to make some kind of a motor stick out of the side like that. Just put a couple holes in the, maybe I could just do it directly to the plastic, as long as these bearings will fit into whatever I cut out. Because, like, no, it needs to be a little bit more narrow. Yeah, the bearings barely fit. But if I could get them to, I could lop off those axles. Then I have to modify the wheels to fit the drive wheels here. Which, I mean, that's not a terrible amount of work. I could probably get that done. Not terrible. No real data sheet. Yeah, because it's all internal stuff. I hate that. I wish they had to use the same microcontrollers as us mere mortals. I don't really want to cut the plastic because that ruins my Mario Kart home circuit. I mean, it's not like I'm putting it together currently anyway, but I don't know. I got thoughts. I got to think about this stuff. Because, yeah, I can hide all the electronics and the battery and stuff inside of this thing easily. And then, of course, I would have to not put all the screws in so that when it crashes, it blows up into a million pieces. That's the important part. Maybe loosen up some of the panels by getting rid of some of the clips. Spray it to make it stronger. So, huh? Spray what, huh? What you talk about? Yeah, because those will hold the shoulder bearings. These little insets here. They're. It looks like they were originally designed for shoulder bearings, but then they decided to use just the plastic bushing because that's all it needs at the low speeds that it does, and it's cheaper. MIPS 2KC 500 megahertz plus video accelerator. Ah, Jesus. Cooling the motor and circuits. No, they don't need that. In the pan car, or sorry, in the touring car, things barely get hot. I mean, if I'm racing for a little while, the motor does get pretty warm, but inside of this chamber here, there should be enough air floating around that it's not going to get to like destructive temperatures. Especially this motor controller doesn't get hot at all. It probably gets warm on like thermals. If you look at it on a thermal imager, it'll probably look warm. But even the most punishing motor doesn't really do much to that. It can capture composite video, so if you're lucky, the camera's a cheap aftermarket automotive reversing camera. I think it's more like cell phone style camera because it's got lots of pins. Here's the connector. It's got lots of pins. Cameras are tough because you never know like what the hell they're doing. You never know what all these pins are doing. Camera transmitter circuit. Yeah, the camera, the RC, like the first person view camera, gets extremely warm, like concerningly warm. But yeah, I don't know. RGB digital is possible? Man, I don't know. That's so many pins. I'm not going to figure out. Like, it's not worth it to figure out what all these pins do. I could probably get a similarly sized camera that fits in this housing. This reminds me of that new robot from Boston Dynamics that's creeping everybody out. Boy, oh boy, do they not have to make that thing as creepy as it is. But it does look like a content warning character, which is kind of funny. Yeah, this is the key, this housing right here. Because this snaps into there, and it just holds all the motor stuff, or it snaps in like this. So I'd have to have the gear here, and then the motor would sit behind it. It'd be very strange. I wish I could move that gear in a little bit, but just by the nature of how this thing works, it doesn't allow for that. It has to sit all the way out here. And then in order to get the even wheelbase, yeah, I have to figure out how to get the wheel to adapt to this, but that's for another day. I could probably 3D print the entire wheel, to be honest. Just redesign it and then 3D print it in yellow. I don't have yellow filament. That'd be super cool, and we'll do that at some point, but not now. For now, we got to work on some of these circuits. Let's get our heads in the game, huh? Start thinking about modular synthesizers and what stuff I still need to do. There we go. I do want it to all loosely fit because this thing will go genuinely very fast, and a big nasty crash would be hilarious. It'll probably break a lot of stuff when it crashes, though. Get those parts all in one place. Oh yeah, and the motor. Is the motor still over there? Yeah. Print the inside of the wheel so it still has the rubber band. Well, yeah, it's not going to have a rubber band, though. It has, the Mario Kart wheels are done like beach go-karts. They're done like those ATVs that are designed to go on the beach. They have these big rubbly tires that are just big rubber. I think they're not glued down. They're just big rubbly tires with no suspension. The suspension is achieved through the squishiness of the wheel itself. But yeah, those are the Mario Kart wheels. So I could print out a different hub, and then it would have the proper mount to interface with that, what do you call it? And I already have CAD files. I already have drawings and stuff. All I need to do is replicate this. How'd you go about it? There's H.264 OMX device on there, which does accelerated encoding, and several others. What, I didn't do nothing, man. I ain't do nothing. I don't know anything about this stuff. Apparently your wheelhouse contains video stuff that I don't know nothing about. I don't know anything about that. I'm going to be the change I want to see. What are you doing? The world needs more steam engine powered RC cars. The only problem with steam engines is that they pop. And when they pop, they really pop. They pop off. Like those things, steam is so incredibly energetic and dangerous to play with. As an engineer, I'm acutely aware of these things. You know, my dad had a little like steam engine, one of those old tin steam engines that you put the little white puck of burning stuff under it, and it runs. And like, he was so cavalier about the whole thing, and I'm just sitting there like, this thing is a bomb. Like, it's a good thing it's got an output on it, but yeah, it's super duper energetic. I've worked with high pressure steam systems before. Well, hey, have fun. Just don't blow up. Don't forget to turn that steam into electricity and then use that, because that's what everybody does everywhere. We invent a new power source, and we're just going to use it to heat up water. We did that with solar. Man, the sun has got a lot of energy. I wonder if we took a bunch of mirrors and put them in the desert and focused it all on one point, we could really heat up that water. Like, that's all we do is we heat up water. Truth be told, we're very, very good at extracting energy from water. Turbines are some of the highest technology out there. and they're incredible and like incredibly efficient and resilient and all that stuff. I've got a Raspberry Pi 5 still sitting in the case. I'm going to try to do a little NDI with that thing. I got to play with it though. Plus turbines look cool. That's true. Man, so I ordered from a sandwich place. I ordered like this Italian Mediterranean style tuna sandwich, and it has like cheese and it has what are they, the peppers and oil on it, and then the tuna supposedly is Mediterranean style, which Mediterranean style tuna salad, you know, oil, tuna, capers, some other stuff, spices, whatever. Instead, I just got chunk tuna thrown on the bread with a slight bit of oil on it, and that was it. That's apparently Mediterranean style. Either they're trying to cut the calorie count and show that the sandwich is like, oh, this is actually healthy, which it's not. It's a hoagie roll. That's way too much bread. But I think they were trying to make it seem healthy, or they were just trying to not provide mayo because it's too complicated and expensive to make or something. I feel like they were definitely cutting corners on that. And then they decided to spin it as Mediterranean style. But it was just tuna on bread. Like, I really feel ripped off by this. I was like, oh, that sounds delightful, Mediterranean style. And just like tuna. It's like, all right, I can just eat it out of the can. Like, I almost prefer doing that. I think we got to start throwing executives in jail. I think that's the only way we get around this stuff. All this unchecked ridiculousness that we got to endure as consumers. We either got to go get the guillotines or we got to throw them in jail. If they want corporate personhood, they should have corporate culpability. I'm not even talking about crimes. I mean, just for like mildly inconveniencing me, they should be thrown in jail. Sounds good? Yeah, exactly. I don't think anybody would really protest that. Just for inconvenient crimes of inconvenience. You will be thrown in jail. Corporate jail. No, you already agreed to it. You already agreed to it. You're signed up now. You guys said it was okay. All right, let's see here. Let's get the music out. Music, go away. I cast music. Delete. Oh, it worked. I have superpowers. Anyway, what are we doing today? Hi. So, welcome. It is the day of hovercrafts around here. It's when they practice for the semi-regional finals, and they drive around all of their hovering equipment that has two-stroke motors that will either gas out the basement and expose me to a lot of hydrocarbons, or just make a lot of noise and get on my mics. So, but the work they do is excellent. So we appreciate them very much, and their ability to pilot hovercrafts all over the place. Anyway, so we're here. I'm in the basement. I got stuff to work on. You guys have seen me flailing, trying to get anything done, and I've not been able to do that final push. The hardest part about building stuff and doing this kind of hobby stuff is that final push to finish something, because you have to then lock in all the crappiness of the thing that you've already built. And so the best thing to do is embrace it and just get it done. There's a couple things that I want to get to today, and things that I want to test, because we're trying to nail down this Hajiwo oscilloscope circuit. That means that we've left the VCO, the voltage controlled oscillator circuit board, in the lurch, because we did a lot of programming with that, and I kind of was like, enough. Put it to the side. It kind of works. That needs a little bit of tuning. That needs a little bit of programming. The diode ladder filter, the other Hajiwo circuit that I was working on, the diode ladder filter, that one's for me only. That one, I haven't gotten it working yet. We did 3 streams or more building it, and I still need to hook it up to power, and then we can go to testing it. I need a little bit of time, though. I need a little bit of time on my own to finish that soldering work so that you guys aren't subject to that too much. I find like the novelty of the different types of things that I do bring in new people. Starting a project obviously brings in everybody because it's a new thing, but finishing a project, it's a ghost town. Everybody leaves, and because that's the hard part about this stuff. So I try to get stuff done in the background while you know, having fresh projects and things that look different. Like if I go from soldering over to milling over to programming, like that brings in a lot of people, and people kind of enjoy that. So I try to keep that going, but at a certain point you get to where I am right now, which is I have 3 projects that aren't finished, and then the big project is of course stagnant the entire time. So Code Rush rating with a party of 33. Hey Code Rush, how's it going? I'm trying to give you as much credit as possible in the VOD channel for all of these raids, because it's so awesome that you bring people over here. I really appreciate that very much. Hi raiders. I was just getting done explaining to chat, who already know this very well, that the hardest part about doing stuff like this is finishing, because that last little bit, that last push to get everything you want done out of a project is the hardest part. Things sometimes fall into line and things kind of very, very smoothly transition into finishing, but usually it's a push to get the stuff that you've been avoiding done, and that makes people flee. The viewers go away when that happens. So I've been trying to skip around and do some new and unique stuff. Like we've gone, like I said exactly this a minute ago, but like when you go from soldering to milling to programming and back, you keep that variety going, you get a lot of new people in. But yeah, we need to finish some stuff. So that's where we are right now. How's everybody doing from over there? We've been coding in Arduino, and I've been actually coding to try to create, where did the hardware go? Oh, there it is. A voltage controlled oscillator that uses an RP2040. That's that thing right there. Xiao. RP2040 Xiao has 4 analog inputs, so it actually lends itself to this quite well, because you have control voltages coming in, you have triggers, you have audio signals, all this stuff that you need to sample in order to make any given synthesizer module do an output. So we have this thing working completely. I will need to reorder circuit boards at some point. I'll probably make them all yellow because the yellow circuit boards look really good. So you're telling us you do way too much. Yes. What was that thing about the mill? What was that again? Explain. Can anyone recommend a home office chair for developing? Don't get high end if possible, no budget. I don't know. Look up Steelcase. Steelcase is a really good company. You want to get something that's perfectly ergonomic and not a race car chair. Those race car gamer chairs really, really annoy me because they're not ergonomic. You know, you're supposed to be in that chair to race a car around. That's why there are big side bolsters to keep you planted in your seat during lateral acceleration. However, they decided that they weren't going to certify or crash test anything, and they decided to put casters on it. They just went and put casters onto a stupid race car chair that isn't even a good race car chair. Yeah, it's do yourself a favor. Yeah, Steelcase Elite V2. What did I get? I have a Steelcase something or other, like an entry-level Steelcase. It was expensive, but again, I'm a big fat ass and I need to make sure that my back is properly supported when I'm using the computer. My only problem with Steelcase is that when you do the partial lean back mode, it's not far enough. In my old office, we had leather Steelcase chairs, and they did the whole thing where when it pivots backwards, the seat actually goes out, which is pretty cool. If you're shopping in Europe, maybe Top Star chairs. I don't know about them, but that sounds cool if they're from Germany. Yeah, we know very much about ergonomics and we build chairs. It's like, okay, I trust you instantly. Thank you, German accented straw man. You can't not. But so anyway, yeah, in terms of like chairs, I really advocate going with ergonomics. And I'm not specifically speaking to you, Scott. I'm speaking to everybody out there who doesn't consider the ergonomics. You can buy like an office supply chair for like $100 and it'll last 20 years, and you have to put tape on some of the foam because it wears away. Or you can buy a race car chair, or you can buy something with the designer's name attached to it that's hundreds of dollars. And I would go with the hundreds of dollars, even the entry-level hundreds of dollars, because those race car chairs are trouble. They're not going to do anything good for your back. I'm anticipating a lot of back problems with gamers. Yeah, and then the other pro tip is offices are closing down all the time, right? They're opening up, they're closing down all the time. So what you need to do is go to a reseller when they liquidate all their assets because they've declared bankruptcy, right? They throw a flag in the dirt and they go, I declare bankruptcy. And then all of these cockroaches come in and steal all their stuff and resell it, right? they buy it all for pennies on the dollar, and then they resell it. When they resell it, it's still for pennies on the dollar, and it's barely been farted in. There's only a couple farts in that thing. And so you can buy these really, really nice ergonomic chairs because, again, companies don't want to pay out. They don't want to pay people whose backs explode because they were on bad chairs their entire office career. Office people sit around to the point where it's actually a health hazard. And if their backs explode, then the companies probably would be liable. So they buy really nice chairs for these people. And also, if you have like a conference room, you want to have nice chairs so that you look like you know what you're doing, right? So they'll resell it for pennies on the dollar. And you can get these nice chairs, nice office equipment for cheap, 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 cheap. So yeah, those are my recommendations. Why do I know so much about this? Well, because I am cheap to the point of a fault, and I'm also kind of a ferret when it comes to finding details about stuff, especially stuff for sale that I'm looking to buy for pennies on the dollar. So I find out all this stuff about chairs, and suddenly I have strong opinions. National Office Interior Sellers. Wait, what nation, though? What nation? What do you, huh? True analog synth with gears and springs. Are the YouTube comments coming in? Yes, they are. Okay, cool. Chicago. Okay, yeah, that's pretty good. Pretty good. Okay. The nation of Chicago. Welcome to the Chicago nation. Wait a minute, you're in New Jersey. Okay, so this is a VCO, right? We built this. We figured out all the problems with it. Still a couple little things that I want to do before I declare it done. We need to build up the cord VCO, which is just a slightly different wait, that's not the right one. Slightly different flavor of ins and outs on this one. And I need to do the modifications to it. And I need to do that because otherwise I won't have vetted out this board. Now, both of these boards have the same mistakes. So I've corrected the same mistakes in both of these, but there might be unknown errors in this one too. And that will also mean going through the software and figuring out how it works, which is going to be a bit of a beast because I think they're two different animals. This one creates frequencies, this one creates chords, and I think this one might be based on an Arduino synthesizer project. So they're doing the same thing. They're doing the same PWM thing in order to make the audio output. But I think the software might treat it differently because this one is putting together notes and this one is just putting together notes. Well, it's okay. It's whatever. It's different. So yeah, that'll be kind of a tough thing to go through, but we'll get into that later. For now, we have been testing out breadboard circuits. And this has been pretty neat. We've been light and agile, and we've been able to put together one circuit per stream. So if you want to get into breadboarding and you happen to have all the stuff on you to do exactly what you need, which took me a while to achieve, you can do in about 4.5 hours, you can build a circuit. That's been my experience. If you're talking the whole time, if you're explaining every single thing that you're doing the entire time, right? So that's what we've been doing. I have a couple ideas of what I'd like to try out. I think for right now, what I want to do is replicate Hajiwo's circuit, and instead of putting in a diode, let's translate that to English. Did my computer restart? I hate how the computer can restart because some programs don't come back up when it comes back. So yeah, Hajiwo's pretty awesome, right? He builds some pretty cool stuff. One of the things that he builds, one of his things, his claims to fame, is a $7 display module for the modular synthesizer. And I think this would be really good because then I don't have to haul my scope out in order to figure out what's going on. And I can give one to Julian. Dave already has one of these, so I can give one to Julian and he'll be able to view signals and stuff. And so these can be control voltages, they can be audio. In order to do that, we need to cater to the modular synthesizer voltages, and they're very much not good for microcontrollers. Microcontrollers can be 5 volts, they can be 3 volts. I don't know if you can find a 12-volt microcontroller. Maybe you can, but 5 volts and 3 volts are not exactly going to mesh with 10-volt plus and minus signals. Now, this is just a display module, right? There's no measurements on this. This is not something that you can use to like tune a VCO. It's something that you can use to just view what's going on. You can just see what's happening here. So I would like to build this because I think it's cute and it would be a really neat little project. Our philosophy with Hajiwo's circuits is to take the microcontroller circuit and then mix it up with Mutable Instruments op-amp designs. And Mutable Instruments is doing similar stuff to what Hajiwo is, except that these things sold for like $300. The similar thing is that we've got a microcontroller with a particular voltage to it. This one has an STM32, which is the 3.3 volt microcontroller. Some of the other ones I've looked at have 5 volt microcontrollers, and that changes the nature of the circuits. But the way that Mutable Instruments is doing it, and it's probably a thing that's already been done somewhere else, and they're just kind of, you know, using that scheme. But the way that they're doing the inputs is by using an MCP 6004, and the MCP 6004 is a lower voltage op amp, so you only give it 3.3 volts. So if you accidentally saturate the op amp, it doesn't blow up your whole system. So we've got a TL074 and an MCP 6004. The TL074 is doing the initial scaling, and the MCP 6004 is doing a little bit of mixing here. But you can do it all in one. You do it all in one op amp. And we tried to do that, but things didn't really operate the way that I thought they should have. I would like to take a look at Hajiwo's circuit, this non-inverting op amp style, and see how that works out. We can just make our 2.5 volt source, and we can put it in here, and we can see what that does with our output. I guess we could do it in parallel to the other circuit too. We don't have to actually break anything down yet, because I'm trying to make it scale 1 to 2, which is approximately the calculation I got from a non-inverting op amp with 2 10K resistors. It's 0 to 10K. And then this is scaling it down. So we've got a 10K and a 47K. So we're taking, the problem is this is outputting it for a 5 volt system. And we have a 3 volt system. So we need to do like a third. So I guess if I do, well, 10 to 4.7, what's that doing to plus minus 5 volts? I mean, I think I've done this before, but a voltage divider is a simple thing. Voltage divider calculator. I don't trust myself to do math anymore. I've gotten to that age. So the source voltage, let's just say we're giving it 10 volts. Or no, we're giving it 5 plus 5, and then we've got 10K. This thing does K. I could just write 10,000. 10K and a 47. Wait, is 10 and 47? Hold on a second. Happy Thursday. Yeah, man. How's it going, Make Mistakes? How you doing? Oh, finishing projects is getting a little tough here. We're doing a little of experimentation here. I want to see what Hajiwo's original design looks like, what it actually does, and then see how that responds to the frequencies that we give it, like we did last time, to see what we can do with our circuit in order to reproduce what this thing does. Yeah, it is 10K and 47K. What does that do? Okay, so it scales it down to 5 volts. So if I do 10K and like 33, 3.8, so 39, 3.9, 40K, 42K. Oh, we're going up, wait. So 30K, 3.7, it's still too much. 25. Really? 20K? There it is. So 10 to 20 would be the voltage divider that we can use in order to bump our voltage down into a proper range. Anything above 5 volts would be saturation, and 3.3 volts is, that's already there. We could go a little lower than that. I could do 19K, but I don't know if I have 19K resistors. So we'll just have to rely on statistics in order to bump that down just slightly. So let's give that a go. So we're going to go 10 and 20 kilo ohms on the input. Oops. On the input. That bumps us down to 3.3, and then we have a 1 to 2 gain in a non-inverting op amp. So let's build that and let's see how that does. And then we have an offset of like 1.65, because that makes that's half of 3.3. So 1.65 or 0. And we'll see if we can replicate what Hajiwa's results are, which is to have this happen. So we have our input here becomes offset by a little bit, or if we, what is this? That amplifies it and that offsets it. We had it offset on the other circuit. It did look like this, but I don't think it looked, I don't know. Goes to the amp and then it looks like that. Well, let's replicate it just so we have it and we know what's what. But we don't know what is what. We just strut. So, all right. So the first thing that I'm going to need, because I have everything else set up already, and we've got an entire side of the op amp that's not being utilized. So I am going to break down the inputs and outputs. I'm going to take the output off of this, and then we're going to take this mess away. So this other side will have stuff connected to it, but it won't be connected to stuff. And if we really feel adventurous, we can probably connect it later. But yeah, that's one input or output. And then the other one comes from this resistor here. And I probably should have unplugged it a little bit more smartly. I should have had a little jumper on there. Then I could remove the jumper. And well, okay, this resistor is gone. This whole circuit is, I guess, getting ripped up. I would have liked to have it still available to us, but I guess not. So what I'm doing here is I'm going to make a voltage divider. Maybe I should put this one back just to make sure I don't lose it, so I have all the components here and I don't forget what's where. I'm going to take this one and shorten it significantly and then just put it in a little further up. So this one goes here to here. And oh, we need power, don't we? I've got, well, that's, hold on a sec. What is that one? That one's ground. So there's ground, but this one needs to go to power, which is over here. So I think what I'm going to do is go in the trough and then back out. So we'll do a couple little bends. For those of you that don't know, this is solderless breadboard. This is a product that you can buy. Typically, you would go to Radio Shack for this sort of thing, but those don't exist anymore. So you go out and you buy this stuff, and what it is a bunch of little metal clips. And the little metal clips can then be utilized in order to push wires into and reconfigure. You can configure and reconfigure, and the reconfigurability is sort of the claim to fame for this stuff. This stuff is so reconfigurable that you can do a bunch of different designs on it, and you can vet out your designs to make sure that they work properly. And so that's what we're doing. And while it doesn't make a perfect connection, it makes a good enough connection for you to test out your circuitry. And maybe if I move this one, well, I can't really move it up because that one goes, well, this one is not necessary any longer. You go away. What are you looking at? Virtual breadboarding games on stream. I wonder how good they are at simulation. Some people meticulously plan their breadboards too. What is that? There's some program that lets you vet out like perf board circuits, and it lets you like design them. Perf boards and breadboards and stuff. I forget what it was called. So usually we would do power on the rails, but we have ground that's active in this circuit. I could potentially just move ground over to, like I could have one be 3 volts and the other be ground, but since we have a limited, we're only using 1 op amp here, and only that 1 op amp needs power. So I'll just run local 3.3 volts. I just throw wires and components at it till it works or it's on fire. Exactly. I do that, but I try to keep things a little bit more organized than the typical breadboard circuit. I think we're gonna have to make multiple jumps just because of the nature of the wires that I'm using here. Unless I move the power supply like over, nah, I don't want to do that. See, this is the positive power supply, and that needs to jump all the way over to there. I think that was a red wire. Actually, due to the nature of this thing, I think it would be better on this side anyway. So I'm gonna cram it in right here, and that way I can do power and ground locally. And it won't get in the way of anything else. A little bit the output wire here, but I'll just kink that over like that. And so we're what? V in, out, grounds. V in is coming from plus 12. Ah, come back here. V in coming from plus 12. Wait, was it in, out, ground? Or no, wait. Yeah. In, out, ground. Okay, so if I do in here, I need a green jumper. Yumper! Green yumper. Fuck! Drop it on the ground. Crumb is the name of one of them? Huh. 75U. What's that? Ground, and then, or sorry, in, out, grounds. That's imp. Can I just stop dropping these for just a second here? In, out, and then this one is ground. Come on. Come on, buddy. You can do it. Yeah, it's been fun kind of getting back to basics and not doing anything too complicated. Breadboarding is one of those sort of like first experiences that you should all have in electronics, and it's still useful all the way up to the advanced stuff. Lurks while setting up, and eating his turkey and mayo sandwich. I had a turkey and mayo yesterday. I ordered a couple sandwiches for the house, and nobody else wanted them, so I end up being the garbage bin. So in, out, ground, so all I need to do is just plug this in like that, and now we're mostly out of the way, and all of our traces, actually what I can do is, oh no, you know what, that would have been really convenient if I could have plugged it in like this. I guess I can flip the two, and then we can plug this in here, and that takes up less board space. Jumperless breadboards? Onboard Arduino setup. That sounds way too complicated to be useful. I mean, it sounds like you can make some pretty clean stuff with that, but yeah, switching arrays, huh? Like, if you're going to go through that much trouble, you might as well just simulate it. Oh, I plugged into this by accident. Let's make that even shorter. Even shorter. Actually, let's shorten both of these. Oh, no, that one can't, because that one specifically goes to my -10 reference. That one specifically is the -10 reference. Saw one on EV blog the other day. It looked awful, way too complicated. And then you've got to think about like what those transistors are doing to your electrons. This one is a straight up metal clip. And so that metal clip just carries current. It doesn't do anything that spectacular. Whereas with like a switching array, you've got to be careful about like, well, what does the switch do? What are its tolerances? Even electronics have gone woke. You need to worry about tolerances. It used to be you could say whatever you want and have the absolute most awful take ever invented on the resistor color chart. There was, don't, you guys post anything like that, I will ban your ass faster than, it's like, fuck's sake, man. We had a stream where I was talking about Roy G. Biv in terms of the resistor color code chart and how I didn't need to memorize it because I don't give a shit. Because you can just look it up. And then people were sharing the whatever it's called, those, what are they called, acronym? No, whatever it was, the memory devices that they used on them. And some of them are racist, and some of them are sexist, and some of them are both. And they have no place in this hobby at all. They're awful and stupid. Really kind of toilet humor kind of level. I mean, we do a lot of toilet humor here, but toilet humor can be very funny. But yeah, those kinds of takes were just not welcome. And apparently, you know, you'll find them very easily if you Google them, but having this hobby become a boys' club is not a good look. I hate it. Interesting concept. Yeah, I guess it is. It would be kind of cool if you could just plug in everything and then like an FPGA does all the connection work. Yeah, that's kind of neat. I mean, they said Arduino, but I would think FPGA would be. I mean, then again, you could just build all this stuff in an FPGA, can't you? You'd have to break it down, but just because you can make it doesn't mean you should. I mean, look, if you're like me and you're constantly second guessing yourself on where stuff should be going on the perforated prototyping board, because I don't like it to be a big nest of wires. I don't like that, because then you brush up against it and you make a bunch of disconnections. But like if that really is eating at you, the solution of having a self-wiring grid is kind of cool, because you just plug in your stuff and you go, hey, I want this to be connected to that and this to be connected to that. I think that idea has some merit to it. That's kind of neat. But in the end, it is well overcomplicated. And I love for people to be doing projects that have no point to them. Projects don't have to have a specific point to them. I know that that's stressed a lot because everybody's engineers, right? And engineers are problem solvers, but not the typical conundrums like what is love. Engineers solve practical problems. I think I just quoted Team Fortress. But anyway, yeah, they solve practical problems and they love doing that. And so if you give them a practical problem, they'll want to solve it. I love engineering for art. I love it because it's pointless. Pointless projects, I love doing them. I don't mean something you're actually trying to do that's like got an actual practical solution to it and you fail. And so you go, well, I guess it was just a pointless project. No. I mean like an actual thing that doesn't have a point. Like the, what is it? The machine that turns itself back off again if you flip the switch. Although the meaning for that was to get blog credit. So I guess that invalidates everything I just said. Whatever. Anyway, okay, back to brass tacks. So now we've got a power source on this thing. We've got it all wired up and ready. I just need to find the one jumper that's going to bring power to our operational amplifier. The whole point of doing these projects right now, all of these VCO things, is that eventually I would like, well, first of all, I want to learn about how analog stuff works. And I've been getting into it, and I've been learning more and more and getting a feel for actual analog circuits in reference to modular synthesizers. And then the goal is to actually start making noises. I can actually make some kind of an ambient, pleasant noise that will fill the background of my stream intro. And then I'll finally be popular and have viewers. You guys figure that? Like eventually I'll actually have viewers. The fart box was a good pointless project. That makes people use up channel points though. That's the purpose of that one. I miss the ability to do transatlantic farts. The beauty of Twitch is that you can tune into somebody's stream from halfway across the globe and fart on them. We'll be doing that soon. I have to stare at the Node-RED. There's a really nice Node-RED GitHub like thing, and I need to figure out how to import it. I'm in the orange here. Is my voice way too loud for you guys? Am I crackling anywhere? Engineering for art. Call this how to get the mechanics to hate engineers. It's true. There's always a schism there between the people doing the designs and the people that actually have to implement the designs. It always has existed and it always will, and it's just one of those things. I may want to slink this around like that at some point in order to avoid blocking where I might plug other stuff in. I think this is good for now, though. We'll just leave it the way it is. The audio seems fine. Okay, good. Perfectly fine and loud. I did a little bit of tuning of the system here in order to make sure that my voice was fully in, because I've been doing all my VODs, and for a while the audio system kind of gets a little stagnant, and like you bump a knob and turn down the volume and stuff like that. So my voice wasn't very clear. It could be that I'm just listening to it through these monitors, these M-Audio monitors that I got 10, 15 years ago, that are not very good audio monitors, but they're good for like workhorse kind of stuff. They're good for having on the stream computer that doesn't really need audio, and I've been using them to edit stuff. So, fun fact, Hitchcock loved bathroom jokes back when just having a bathroom in a movie was taboo. Yeah, that used to be controversial. Hitchcock showed a bathroom in a movie and it was controversial. Like, people were wound up, man. They were wound up. In other words, Hitchcock walked so Apatow could run. Something like that. Hey, I saw Freddy Got Fingered in the theaters, and it was in theaters for a day. Nobody likes M-Audio. Nobody likes it, but they all have it. These are the M-Audio monitors. They were on like some super deal website at some point. Yeah, Daddy, Would You Like Some Sausage is one of the better bits that I've ever seen in comedy. That was one of the better things that I've ever seen in comedy. And I've watched quite a bit of comedy in my day. All right, so we are building this circuit and we have a very limited amount of space. I'm going to put these back over here and just put them right there. So we've got ground and we've got power. This ground really bugs me. I'm kind of annoyed that we implemented this circuit in the particular location that we did, because that means that I need to have this jump crookedly in order to get to ground. Very annoying. We could do one of these. Get a little kink to the side. M audio is better than no audio. Yeah, only by a little, but they M audio, I'm not going to say they make great products, but their stuff works and it was cheap. These monitors sound like boxes, but that's not so bad. That didn't really solve the problem. That actually made it worse, and now it's bugging me even more. I'm going to leave it alone, though, because I need to move on. So we've got the same filter that Hajiwo has over here. We've got a different pinout because we're on the other side of the chip, and we need two 10 kiloohms, three 10 kiloohms, and a 20 kiloohm, and through-hole resistors. So I am going to look at the pinout. I'm going to have that up. The wonderful thing about having so many monitors in front of your setup is that you can drag things like schematics and calculations and notepad drawings. You can have them all right in front of you. This setup has been a long time in the making, and a big deal was moving the monitor up. I used to have a monitor down, and so whenever I program stuff, I look like this all stream, which is not a good look. But this is what I've done. I have put monitor stands on the two peripheral monitors so that I can move them around easily. And then the center monitor is on its own stand because I bring this one's the one I take to LAN parties. But I have three huge monitors on the upper shelf of this thing and barely enough room to put my garbage on that top shelf. Cool thing about having a monitor on the top shelf is that you can hook it up to the scope. And so when somebody's breathing down your neck with coffee breath, you can have them look up instead of looking down over your shoulder and breathing on you. Used to get breathed on by the senior engineers walking around, going like, "Oh, what are you working on?" And I'm like, "Get your fuck breath out of here. Go find some gum or a mint or something. Jesus fuck Christ. What am I building? None of your business. Get the fuck out of here." Now, I am building we're building a Hajiwo circuit. Hajiwo is a YouTuber who builds cheapo modular synthesizer stuff. And so we're working on this oscilloscope. It's basically an oscilloscope. It just doesn't have measurement capabilities so that I can view what's happening on screen. Or sorry, I can view what the control voltages and stuff are doing on the synthesizer. I figured this would be a fun little break because we get to do some prototyping and breadboarding, and we get to get into some of these analog circuits a little bit more than we would if we're not just completely recreating the Hajiwo module. We're actually getting the concepts and trying to apply them to the type of circuit design that I like, which is stuff from mutable instruments. So we're doing a big amalgamation of designs here. This is why a popped collar was invented. In college, one of my roommates was going out that night. Three popped collars. Three popped collars. There were three, and they were different colors. He was wearing three collared shirts, short sleeve collared shirts, and all three of the collars were popped, and he had a hat on backwards. I changed. I saw that, and I changed that day. My lookout on life and sort of our existence on this planet changed. Says the guy with weird long hair. Okay, so I need to get a haircut. I'm sorry, I'm bad at scheduling things. Hajiwo, display module. We need to get to the point where I am hooking the digital up to the analog. We'll get there, but the ouch says, "Neat, this is all new to me. I've been into technology since I was a kid, but this is far beyond anything I've ever done. Been watching for a couple days. Glad I found your channel." Hell yeah, brother. Or sister, I don't know. But yeah, doing electronics is there's a vast amount of things that you can do. If you want to get into building things with electronics, the best thing to do is to improve something. You say, "Hey, I would love it if a light went off when somebody opened my door." And so you got to look into how to do that, and you start with a perforate prototyping board, maybe some how-tos for electronics. I haven't started out since the 90s, so I don't know what to do. I don't know exactly what to buy. I started off with a very basic book, and I took a lot of margin notes about how everything was functioning and doing. You kind of start with physics, and you teach yourself how to switch things. Never follow a tutorial that tells you to plug stuff into the wall. The wall outlet is dangerous, and it used to be that there was no other way to start in electronics than making your own power supply. You don't have to do that anymore. You start with 5 volts and 3 volts, and you make digital circuits, and you can do some really genuinely impressive things. I've seen a lot of very cool art projects that where the artist doesn't really know how to program. They just know that, okay, I can hook up voltages here, and okay, the LED flash, that's all I really need. And then they'll build it into something that's really, really cool. I love that. I love how accessible this stuff is now. But yeah, I've been tinkering my whole life as well. And during that whole process, I've never gotten into the analog audio kind of stuff. My friend has been pushing me, my buddy Julian's been pushing me for nigh on 20 plus years to build him a synthesizer. And so he gave me his old modular synthesizer cases because he expanded into something that he could take to shows with him. And so that's what you're looking at here. You're looking to burn the subs, the RC car stuff, and modular synthesizer hell. I discovered that we can buy the circuit boards and just build those, and they're like, good luck, asshole, which I love because that means that I need to struggle and find answers and figure out how to make stuff work. If a project is worth doing, it should scare you just a little bit, because that part that you're scared of facing, confronting that, is where you grow, and that's how you get good at this stuff, or kind of not terrible at it. Was there ever such a time? Lots of devices shipped with like a 9-volt AC power supply, slightly floaty, unrelated. Well, so I'm quoting from a bunch of books. I originally learned from books because the internet wasn't a thing my entire life. And so I started off with these books that may have sat in a library since the 50s. And so opening up these books, they're like, here's a 10-to-1 transformer, or a 10-to-1 transformer. Plug that into the wall with no fuse or anything like that. And look, you've got a 12-volt AC power supply. Now we can start to build circuits. And I'm like, whoa, no. Like 5 volts has been around forever. Where 3.3 volts has been around for a good amount of time. We've got like 1 point something volts now too. Like, don't get into DC and digital stuff first. Oh yeah, those big lantern batteries were also big back then. Been in business doing computer consulting for 24 years. Oh, neat. Very neat. What did I miss? Played around with Raspberry Pis, but never built anything with them outside software like digital picture frame. Raspberry Pi is, I think, in my opinion, well, I don't know, my opinion's getting old. I always see them as being too powerful for stuff. I appreciate the limitations of a basic microcontroller and trying to get something working in code in a basic microcontroller, because then your limitations can frame how you put together your project. They can help simplify things and keep things from ballooning out of context. The thing is, like, here I am, and of course, this is the part that I shouldn't do. I shouldn't say these things, but here I am with 52 viewers, which is really, really cool. It's a nice amount of people. It's manageable, and I can actually talk to you guys one-on-one. But when some particular streamer, I guess former, well, also YouTuber, puts together something with a Raspberry Pi and like a big complicated audio thing, and they just take big blocks of code and put all the big blocks of code together in this very complicated microcontroller that's just acting like, well, very complicated embedded system that's acting like a computer in order to just simply set off an audio cue in what is essentially an RC car with a Roomba shell around it. They get 20,000 viewers per stream. So there's a difference between my being a little bit like, ooh, it's too powerful, and being able to just systems engineer stuff and just put it together quickly and punchily. So there's definitely a schism there between popularity. Although you can buy an Arduino kit and do exactly that project. But it was very funny, which is something that I strive for. Anything going on over here? No, just the comment about Hancock. Projects that lead people straight to the microwave transformer. Encourage natural selection. Oh my God, it's like those Russian YouTube channels where they have a giant wire and they make it red hot, and it's sitting on a floor in a shack with a bunch of garbage around it, and somehow they don't burn down the entire shack. Actually, I think those guys were Ukrainian. Or they hook up the microwave inducer so that you can open the door, and then they blow up a cell phone with it. And it's like, I'm cool. I don't need to do these projects. I'm good. Resistors. We need resistors. That's what I was doing. You guys are just getting me on all of my speeches today. ADHDing me out of my own stream. I've been playing Fallout 4. Made a little bit of progress last night. I need to focus on the plot and not the base building stuff. Because if I get to the base building stuff, it's Jover. I'm done. I will never see the light of day. All right, here's 10Ks. Bought some extras of those. Let's get a 20K going here. I don't know if I have 20K, so I might have to double up the 10Ks. There's two 10Ks, and then I need a 20K in order to pull us back down to 3 volts in a voltage divider. Voltage dividers are like Circuit 101 things, and I got made fun of because I didn't know that they were called voltage dividers because of the way my classes were structured. What if we do 22 might go over, right? We went all the way down to 20K. 22 is going to overshoot a little bit. Let's find out by how much. I'm excited for the Fallout London mod pack. Oh, that sounds kind of cool. I would like them to get away from just California and the surrounding area. Calculate. 3.5, 3.438 is possibly manageable. And the only other direction I have to go in would be much smaller, which is... Wait, this one's not labeled. Oh, 39? That's not quite right. 39. This one is 47. So yeah, we go from 15 to 20 to 33. 33 is going to undershoot significantly. Let's just see what 33 gives us. Because 3.4 volts I don't think is going to blow anything up. Plus, our op amp will not be able to do anything with that. Wait, what was I looking up? I was looking up not 33. 39 I know is going to be... Yeah, that's almost 4 volts. 20... What was the other one? 20... It goes 15, 22. 15 is going to be outright to 30. I guess we're just going to do 22, yeah. We'll just use 22. There's also the next gen update for Fallout 4, which is interesting. I was like, next gen? I thought Fallout 4 was this gen. And then I looked up when it was released. I was like, oh, 10 years ago. Oh, okay. Fallout's got some staying power, that's for sure. I never played much past the what was it? How many hours did I have in that game? It was like 90 something, and it was all base building. I did base building for a long time, and then I didn't ever get back to the plot. Yeah, potentiometers and meter. I saw somebody use a Lego minifig, and they made the 2 little claw hands. They put some like copper tape on it, and so they soldered to the copper tape, and they had a little minifig that would hold on to the resistor and give you the value. This is why I like surface mount. I don't like looking up values like this. I look at if the value is just written on the top of the resistor. Fractal wood burning. Oh yes, fractal wood burning is the process of putting a conductive liquid, salt water, on wood and then hitting it with a shitload of high voltage. There is a reason that I do not do high voltage. Didn't Electro Boom have a scare recently where he injured himself? I thought I saw a tweet of that nature, and it's like, I don't mess around with stuff that can hurt me. I just don't do it. I'm already diabetic. I don't have a functional pancreas. Well, okay, I don't have a functional section of the pancreas that does the very famous job of creating insulin. And so I don't want to deal with any other non-functional organs freeloading on my ass. Is not an organ entitled to the sweat of their brow. What are we building? We're building this little guy right here. And so while we don't have the 4.7 oof yet, we'll play with that later. Right now, I need to build just a voltage divider to ground, but I'm not going to directly skip to ground. I'm going to skip to a location on the perforated prototyping board, because we need to be able to put a 2.5 volt source on that ground. We need to be able to swap it out. Does high voltage PPE expire? I guess the rubber gets hard, right? I have some high voltage PPE just from the free cycle stuff that my friend does. He dropped off a whole bunch of electrical stuff, and it was actually a lot of really cool stuff. So I've got these big, stinky gloves. So this is going from the positive lead of the op amp. So, oh wait, that was up on screen, wasn't it? The positive lead of the op amp. And so the positive lead of the op amp, according to the pinout, which I'm going to open up in this screen, let's see, pin 8 is, well, this is pin 1. So pin 1 is output, and then we have minus, and then we have plus. That's this one right here. So this location right here is now going to be our new ground. And that new ground can be subject to 2.5 volts or just ground. So we'll put a jumper here to go to ground. So I need a yellow jumper. I need to get back to game streams. I need to get back to My Summer Car and all those other wonderful games. So that one goes to ground. This is potentially a 2.5 volt trace. I just pull this up and then put the voltage into it. That one is actually ground. So technically I could have jumpered right to here, but then I would have to supply a different voltage to the microcontroller, which we're not doing. We're not, the microcontroller gets 0 to 3.3 volts. It does expire. That's crazy. So you got to be safe, right? So our input is coming from over here. Our input is coming from over here, and it comes from this pin right here. So that pin I need to bring over to a resistor over here. So maybe we should go this way with the next one. And that is one of the 10Ks, one of the many 10Ks of this thing. So 10K like that, and I'm just going to bend these. I'm using the tweezers as a means by which to set a distance that I bend over the lead of the resistor. That way it sits flat. And resistors are not expensive, so it does not make any sense to save them. I throw them out regularly because it's $10 to buy 10,000 of these things. But bother, that's so wasteful, yes, but you know what's even worse is when you have a breadboard circuit and all of these components have these manky leads and you can't tell tops for tails. I don't know, what's the phrase again? You can't tell anything that's going on. You don't know what the hell, it's just, everything is haywire, literal haywire, hay and wire. I'm actually going to bend these a little further down. And yeah, it's just so annoying to have to troubleshoot somebody's circuit when they build like that. You know, you can get away with anything as long as the electrons flow, right? But I chop the legs off resistors and use them as jumpers. Well, sometimes when I'm soldering like a perf board circuit, I'll do that. But it's just a little shorter. But I mean, like well, at least at college, you would get these resistors that are like on their last legs. They're just about to explode because they've been used in so many circuits, which is all well and good, but when you actually put them in the perf board, they become a liability because maybe those weird leads aren't interfacing correctly with the clips that make up the breadboard. So that one goes to input. So that one needs a wire from here to here. I can go down and over. I can go through the trough, which will probably be more annoying than it is useful. Well, I'm definitely not going out and around, so let's get... Oh, that one's in the wrong one anyway. Get that all the way like that. And then, let's see. So I'm going from here to here. I might as well just go this way. So let's do that. Let's find a good jumper for that. Might need to make more than one bump. Donald Bump. I mean, one of these goes to the input of... If I could just get that a little bit further than the orange wire, I could have it plug in here-ish, and I could move this up, and then our input to the other one would be preserved. That way we could use this circuit. Well, I don't think that's strictly necessary. I'll do it anyway. I'm going to move that up. Actually, move both of these up and move the power down. Both of these up. Because I could, if we really want to get into it, we could actually make both of these active at the same time and then have a comparison. We could do a direct comparison of the two. I could plug it into two traces even on the oscilloscope. Although one has a 100K potentiometer, the other one's just going to get the 10K. So like that, and then power to the circuit from here to here. Careful now. Carefully. Okay. And then red wire to this pin, which is our input, and that goes to here, which is the wrong pin. I can move it over one. Actually, I think I can get this to stretch. Nope. Okay, we'll go to that one. I'll move it over. Everybody moves over. This one comes over here. And we'll just move that over. Nice. So moves over by 1, 2. It's warm in here. I'm sweating. I think it's like 50 degrees out, though. I need to open the window more. And so this whole thing shifts up 1. You got to watch out for parallax of this thing with perforated prototyping boards. Wait, yeah, parallax will mess with you. It's when you're looking at something and you think that it's lined up, but it's actually not. So you gotta kind of tilt things and take a look at where they actually are. It's on that pin, which is there, to the input to the 1 op amp. And then here we can go down to where this one is. I probably should have left that so that I could extend it a little bit more. This is kind of an awkward spot, but Satana. You get out of here, Satana. I don't need any of your inputs. V2, boy, V2. Okay, so now our input is routed. Oop, there we go. Input is now routed to the rest of the circuit. Now I need to make sure that that's actually input. Yeah, that is input. That's input from the frequency generator going into the first 10K resistor, and then the second 20K resistor goes to ground, which we can interrupt if we need to. Then I have, from that voltage divider, the input to the op amp, which is directly from the 10K, directly from the voltage divider. So we built that on the positive pin. The negative pin has a 10K to our virtual ground. So let's get that figured out. So that would be the negative input is, where's our chip? Right there. So that one goes, just basically goes over here. And I do actually have a tool that I can use for this. That's kind of fun. They're a little bit expensive for what they are, because it is just a piece of plastic, and you can do a variety of different, you can do all kinds of other techniques in order to bend these things. For now, I've been kind of raw dogging it and just using my other tools to bend the leads, but this thing right here is actually built for these kinds of things, for perforated prototyping boards. What it is it's a little measurement tool that has 2 little spikes on the end, and what I do is I basically just go that distance. So I'm going from, where am I? Where am I going from to? From this pin to this pin. Hold on, I just gotta put it in the 2 pins and then lock it down. And there's a little notch right there where I can put my resistor, and I can put it wherever I need it to be. I'll put it right in the middle, bend the leads down, and then cut them to length based on this piece right here. And so immediately I have the perfect length component. Sort of. Yeah, this is pretty decent. It doesn't stick out at all. So that's kind of a neat one. I think they're like 30 bucks. Hold on, let me look it up. They're way too expensive for what they are. Go to Amazon. No. Breadboard. I need another keyword. I think there are some 3D printable ones. Some 3D printable ones are, there's also one that's, it's just like a block that you measure with. You just put the resistor on one piece of the block and then you can bend the lead. Like, yeah, this is for other types of bends, I guess. Should learn how to use this part, because that looks like it could do some cool stuff too. Like right angles and stuff. The 3D printed one. I need to somehow repair this one, because I've got a spike here, but then that one broke off. I was just going to order another one, but I think it's pace, so it's way too expensive. Yeah. Made in Laurel, Maryland. I could drive there right now. Conform. Come for me. See, I'll stand my ground. Conform $50. Holy shit. Jesus. What the fuck? Is there a 2? It's underwear. It's all underwear. It's all underwear. It's just underwear. Craft clay desiccant packs. Yeah, so that's 50 bucks. So that's a little bit much. Try eBay. Conform 1. No, nobody has it. Well, there are other tools, and there are 3D printable tools that are similar to that. I just happen to have that one. No, I don't. Amazon doesn't have that much NSFW stuff. You get a little bit. I was looking up beer taps. Holy shit. That was a long time ago that I was looking that up, but still, beer taps can get particularly saucy. So wait a minute. So that goes to ground, but then the other side, oh, it doesn't just go from output to ground. This one goes to ground, and then the other part of that goes to the potentiometer. So let's do that real quick. So we're using, yeah, it's an open circuit on one end. So we just need 2 more jumpers, and then we've got our circuit pretty much wired up. 3 more, because I have to do the output. I actually have to be able to see what this thing is doing. So we can do outside here, and one of these goes to the, not that one. Oh wait, did I do this wrong? I did this wrong. Wait, that one's ground. That one is plus. Okay, yeah, plus to there. That one is minus. Minus with the 10K to ground, and then minus with the potentiometer to output. So one goes there. Well, one goes here. Yeah, because pin 1 is the output. That's right. Pin 1 is the output. Yep. Slightly longer than this. I don't have anything longer. Okay, so we'll just have to deal with this overlapping. Would be nice if I could get this clean, but... Well, I guess what I could do is jump output over to... Nah, it doesn't really make sense. Like if I did a flat jump, then it would be a little cleaner, but... This is fine. We can just get this thing done. There to there, there to there. Try to just like tuck them in over here. And then we can go from output to this pin right here. But you can see the scope starts to bumble around because that's the scope input. And we need slightly less wire than that. Maybe a green. I know some people actually just make their own jumpers for this. Motion detected at the front door. And my dog goes psycho. Whoa, 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 whoa. I put a video of her barking from my gaming computer. Once accidentally clicked on what I thought was anti-static wrist strap on Ali, and then NSW stuff followed for me for weeks. In Amazon, at least, you can go through your browsing history and delete stuff. You should get very familiar about that, with that. Then NSW stuff followed. It turned out to be a contraption made out of the same straps as electrodes for the purpose of stimulating a thing. I'm guessing it's something to do with sausages. Because, I mean, what's his name? The EV blog. He went over some of those things that were designed to stimulate sausages, and it's 120 volts with 2 spikes. And you put the sausage on those spikes, you plug it into the wall. Apparently sausage is conductive enough that it'll cook itself with the conduction through the meat. I don't know, that seems pretty safe to work for me. I don't understand. I don't get it. I'm totally ignorant of anything. Anyway, let's test the circuit out now that we've built it. My dog is still barking. I'm sure you guys can hear barking a storm up behind me. Okay, so this thing should technically be set to the same stuff that it was yesterday, which was a sweep from 0 to 500 kilohertz. Which it is. All right, cool. Now the Agilent power supply forgets. Some power supply to remember, some power supply to forget. Mine forgets. So I'm going to unhook the power leads over here. That's right, it was Big Clive, sorry. Big Clive was the fellow who did that. I like Big Clive, he does a lot of cool stuff. Big Clive here. Hello, yes. 12 volts. And then negative 12 volts. A classic setup. And then this one I'm going to take to 1.65. Because that is the halfway point of 3 volts. And this is an accurate enough power supply to properly have all that stuff on there. So now I can turn it off, and all the leads turn off. This power supply, I wish had a little bit of persistence of memory to it. I wish it had some persistence of memory. I didn't steal it for nothing, but that one feature really annoys me. I found him from Fanny Flambeau Doll. What the hell even are those words put together? I don't know what to make of that, what you just typed. What did you just type? What did you just unleash onto my chat? Some kind of weird fucking... All right. I don't understand at all. So right now we've got a sweep going, and because I've got this handy-dandy awesome scope, I am getting all of my money's worth out of this thing. I can actually put the oscilloscope view on camera. And if anybody buys one of these scopes, leave Rigel a note and say the only reason you bought it is because Oh Bother gets so much cool use out of his. Give me credit. I want them to know I exist. A quote-unquote action figure. The quotes are doing a lot of work there, and I'm a little bit concerned. You have to see it to believe it. Oh, I hear my dog marching around. What is she doing? Willow, come down here. I guess the door's closed. I wish that dog still came downstairs, but she hurt her leg, and so she's been taking it easy on the leg. Okay, are we ready to power this thing up? Drum roll. 3, 2, 1, power. Oh, there it is. Look at that. Whoa, that's super weird. It's like saturating. And I have no control over it at all. There is a mistake. I've made a mistake somewhere. So this is a +5 to -5 sweep. Actually, it looks like it's +2 to -2. That's weird. It should be +5 to -5. I think this thing can't quite handle the voltages. But this should be able to give it like a little offset. It's not doing anything. It's doing nothing. And it's supposed to be between minus and output. So it is between minus and output. And then output's over here. Minus and output. 10K. And then this is a 10K potentiometer. Yeah, that's a 10K. We got a 10K and a 100K. So this is the 10K. Double check my wires. Well, that looks good. These two are going down to ground. Make sure that they're making good connection. Jiggle the handle a little bit. Make sure everybody's connected properly. Get rid of the ground. Nothing happened. Weird. Let's put that ground back in. Make sure my ground over here is good. This one's good. There's always a little bit of wiggling that you got to do in order to get this stuff to work in the end. Double check. That would be ground, output minus plus. Plus gets our input and a resistor. Voltage, that'll be the voltage divider here. Between, wait a minute. Yeah, input voltage, okay, so input voltage comes in over here. Here, let's do this on the microscope. I can't believe you haven't seen Fanny Flambeau's Big Clive's fourth most viewed video. You'll find that about a lot of stuff that you think that are essential for being in the know in this hobby, because I want to have my own unique take. While I love collaborating, I would love to figure out how to collaborate with Uda Oo. I can't really watch other people's content because I'm too impressionable. If you ever drop into the AVE subreddit, you will be shocked to learn that everybody's trying to sound like AVE. And it's fascinating, but it's also kind of horrifying. Okay, let's get this out of here, and then let's get the scope back in. You guys can see what's happening there. So here's our input here, coming in through this pin, in here, jumps over to here, and it goes two directions. This is one of our circuits. This is the other one of our circuits. So in the other one of our circuit, the one that we're working on right now, we have our input wibbly wave come in, and we have it go through a 10 kilo ohm resistor. And that 10 kilo ohm resistor is set up as a voltage divider with a 20 kilo ohm resistor. And this one is in fact 22 kilo ohms. The more ohms I get on this one, the weaker the pull to ground is. Now this is connected 20 kilo ohm resistor that connects it to ground, which is what this, oh God, I saw the Meowcat explosion right here, and it was right inside the pin, and I was like, wait, is something like shorting out in my ground plane? Watching it is your homework after stream. Yeah, I guess I'll have to figure out what's going on. God, I really thought that something was like, for some reason there was a flash of light coming from one of the holes of my breadboard. So anyway, this 20 kilo ohm resistor right here is pulling it to ground, and that's what's lowering the voltage, right? We have a 10 kilo ohm coming through that limits the amount that they can get through here, and then we're pulling it down to ground with a weak pull down resistor. Now this pull down resistor, 22 kilo ohms, so it is rather strong, but it's not quite pulling us down far enough, is it? But the offset is all weird. So what we should be able to do, now this is into the positive pin. Let's double check that. Double check that I didn't get my pin out twisted, which is this one. From pin 1 is our output, pin 2 is negative, pin 3 is positive, pin 4 is ground, or negative. Well, in this case, ground, because we're only limiting ourselves to 3 volts. Can't we just stop the rhyming? No. I will be rhyming, and I will be making the hottest electrical engineering rhymes in existence. No, I won't. I'm not talented. What are you talking about? So we've got, oh, wait a minute. Dun, dun, dun. No, wait, no, that's correct. That's correct. 10K to ground over on the positive lead. No, on the negative lead, we have 10K going to ground. And then from that lead, we go through the potentiometer, bam, bam, into our output, because that's our feedback. In a what is it? A non-inverting amplifier, which I have sitting right here. Non-inverting amplifier. So we're taking the negative and we're taking our output, we're feeding it back into negative as a voltage reference, and that amplifies in the positive direction. I can't believe you haven't seen Flame. Oh wait, no, I already got that one. Chat's very slow today, which is fine. Also, how's it going, Skulldrazer? How you doing? Oh, I've clicked on a scene. There we go. I was like dragging and dropping a scene for some reason. So, all things considered, given that we are like within spec, why isn't this circuit working properly? What have I done? I have 3 volts ground. Is 10K? No, that's not. That shouldn't be it. 10K should be fine for a lower voltage. This, by the way, this was set up in 5 volts, but we're using 3.3. But I mean, the negative saturation, I guess, makes sense. But then when I adjust things, that one gets up to 3 volts. Then if I go in the other direction, it gets above. So, I mean, stuff is happening. I'm just going to play, yeah. It looks like I'm only influencing the outset, the part of the wave that goes downwards, which is very strange. These are properly connected to ground, right? Ground, ground, yeah. 2 grounds, this thing comes around, it comes into, oh no, that's the output, sorry. This thing comes around, it goes into our 10K ohm resistor. Make sure that that's correct, it is. It goes into the 10K ohm, that is a 10, what is it? I hate resistors. I hate them so much. I hate them so much. Colors aren't numbers, okay? Colors are not numbers. I don't know where you freaking things get off. Absolutely ridiculous. Colors aren't numbers. Taking crazy pills. I'm gonna shorten those leads. Maybe those leads are what's at fault. I can get shorter leads than this. I know a lot of this stream is Old Man Yells at Cloud, but still. Don't you try to outslow me, I'm Chat. That's way too short. Yeah, there's a big gap in the distances here. I don't have anything that's longer than this red until I get to the longer white one. So I guess I had the right one in there. I just don't have that length. These kits aren't very comprehensive. They're cheap, but they're not very comprehensive. Yeah, I run into that a lot with my own schematics too, where you're like, wait, this is negative 10 volts. This should have a downward arrow. Otherwise, it's objectively wrong. Goes to the output. I mean, even without the feedback, it's like not doing anything. I just dropped that. This is frustrating. What Hajiwo thing? This is, yeah, so this one is this guy right here. The $7 DIY Modular Synth Oscilloscope and Spectrum Analyzer. It's basically just a display. The schematic is found on his, did I close that? I may have closed it. Okay, let's open that up again. I'll link you to it. I'll put it in chat. Here's his note page that has all the stuff. Yeah, what the hell? Go to the site, stupid YouTube. And that was coming from YouTube. Yep, that's the link. That's my full name. My name is known. What dropped off? Is it just a jumper? I thought I heard a tool drop. Okay, whatever. If it's just a jumper, I don't care. Okay, so weird stuff's going on with this, and part of it may be that I mean, this should be like a 1 to 2 amplification. It's just not. So what happens when we put 2.5 volts onto this jumper? I'm out of clips. So we're going to this junction here. And then I need a ground that I can clip to. Let's go over here with this. Or rather 1.6. That didn't do shit. I mean, it like scales it a little bit, but it doesn't really do much. Weird. What could be the problem? Colors can be numbers in hex code. I guess. All right, unhook 1.6 because it doesn't appear to be doing anything. I have a feeling that like calculations are off because we're not operating in 5 volts. Which the Hajiwo circuit is designed to go to an Arduino, and I was going to put it into a PicoPi because it's cheaper. Oddly enough, a PicoPi is cheaper than an Arduino Nano. I guess a knockoff Nano is cheaper, but this isn't creating exactly what I was hoping to see out of this thing. It's saturating at 3 volts, which I guess is where it should be saturating. So it's 0 volts and 3 volts, it's saturating, and this thing is amplifying. Well, it's not, it's sort of like unamplifying. So if I have a smaller wave, if I actually take this and turn the amplitude down to 2 volts, so I need to hit it twice. I don't know how to use this thing. 2 volts. And we, whoa, oh, I see our, there we go. And I bump this up a little bit. I mean, that's, wait a minute. But like, take that out. Put this in here. Nothing is operating the way that I believe it should be. I'm not getting the same results that I should be getting out of this. According to everything in my notes says differently. It seems like this should be offset a little bit more. Really, the supply's been okay. When I got the PicoPis that I got like a whole bushel of them because they were cheap, and then supplies were really bad. Got to run to do some auditing. Oh Jesus, have fun auditing. Sounds like you're doing Satana's work. Audits are no fun. Oh, but it needs, wait, it needs to be, no, that is in 2 places. Yeah, that is in 2 places. Both the voltage divider and the whatchamacallit are getting 2.5 volts here. And of course, he's making the 2.5 volts with the most convoluted thing ever. But it's supposed to be 2.5, and I'm doing this on 3.3 volts, so I'm having the voltage, so it should have the same effect. We also altered the voltage divider in order to get it into proper range, because with a 5 volt signal, you have 10 and 47K, and then I'll bring you down to 2.5, or no, that'll bring you down to 5 volt maximum from your plus minus supply. And then of course, this is just limiting, that's just protection. In our case, the protection's coming from the op amp, where the op amp is unable to get up to those voltages. He's already made another module. Oh no. Mr. President, another module's dropped from Hajiwo. Scramble all of my people. What'd he do? 13 days ago. Oh. So if I look up scope, has he done? Because this is the one that I found. This is a Korg N2 first impressions, and then $8 overflow folding VCO, which we actually have. We actually have. Our VCO does work with them that way. Has he gone back to the display and done anything with that? I don't think he has. Yeah, he really does. It makes some really cool stuff. Does his note site have it? We still need to finish this diode ladder, by the way. I've got too many of these things going at once. I didn't have any chance to work yesterday. I did uploads, but I wasn't able to get anything else done. Yeah, 13 days is about strain CV, Uno R4. I like the stuff he's doing with the RP2040. I think that's really cool. Biofeedback CV. That's pretty neat. It says here you're under stress. Okay, so our circuit isn't doing what we wanted it to do. Yeah, the SSD 1306 it's too bad the circular display is so expensive. Because like these things are nice and cheap. You know, 13, 14 bucks, 12 bucks. If you go from AliExpress, of course, it's much cheaper. I just use Amazon because I have a warehouse basically in my lap. But somewhere, where are those circular ones? There are ones that are watch face designed. Those would be really cool to put on a modular synth. They're just not listening. Let's do circular. 20 bucks, that's not too bad. That's TFT LCD. CS, SDA, SCL, ground. Chip select, DC, and reset. I think those would look pretty splendid. But none of them are OLED and monochrome. So you'd have to do a whole design in order to get that thing running, right? How easy it is to attach those OLEDs to a Raspberry Pi. I wonder if they could fit in the MTA project. The person that you might want to ask about that is Cluck J from the Discord, because he built an entire like bookend, a cyberpunk bookend that had a whole bunch of screens in it. And so he had a Raspberry Pi running like 6 screens. Using round pixels is the future. Well, actually, old phosphorescent TVs used to do that. That's why when you zoom out on stuff, everything would become circular. Or unfocused things. I think we started with weird round pixels. Okay, so this thing isn't performing in the way that I want it to perform. I don't know what the heck is going on here. Let's try to put a 47, what was that value? Yeah, the Raspberry Pi it's a juggernaut. It can do a lot of stuff. 4.7 microfarad. These are all nano. 4.7 nano. He didn't say polar on that one. Well, we could put a 4. The biggest one that I have is 82 nano in this kit. I have larger capacitors elsewhere, but it's just what's in front of me. Yeah, you can use whatever language you want. You can run a lot of stuff. It's very powerful. Very, very powerful. So let's take the input and let's move it over to another hole. Something sex joke in this location of the stream. I'm not going to make it though. All right, so there, and then we can go across like that. And now we have killed the DC. Oh, you guys can't see shit. We've killed the DC component. That's what that switch is for. So now we are centered. And if I turn it up and down, this does nothing. Then I do shit. Look at that. It's just making the voltage follower a little bit more followy. What did I do wrong there? Let's give it, oh, we're giving it 2.5 volt reference, and we can take it down now, and I can give it ground reference. So that actually works. 1.65 volt reference, rather. So now it has ground reference, and it barely functions. There's a little bit of response from it. Everything's so low voltage, though. So this is through the capacitor, and the capacitor's killing that AC component, but it's not being represented. And so when I give it -1 volt, 1 point whatever, we get a full swing from 3 to 1, and we're giving it 2 volts right now. So if I give it 5 volts, which is 2.5 volt peak to peak, can I turn it down enough to completely die? Okay. Hello? What did I push? Putting on a push. There it is. I mean, that's not a very good representation of our wave, to be honest. Whatever is going on in here, it's like it's almost making a triangle wave out of it. It's making a mockery out of me with triangles. Yeah, the input is set right now to AC because well, barely. I mean, this isn't the 4.7. This isn't the full 4.7. This is 0.082. The cap of the input 4.7 should center it. Otherwise, any signal coming in will be from ground to plus V. Yeah, DC coupled. So that was what we were looking at before and why we had that ground cutoff on it. But now we're decoupling it and we're taking it to an offset voltage, which again, we're working with that offset voltage on the voltage divider, as well as on the part of the, here, schematic. Where's my MS Paint? There you go. So yeah, we're here. And so the audio signal going positive and negative here comes in. We defeat the DC component, get rid of the offset. We scale it with our 10 to 20K here so that we get it down to maximum 3.3 volts. And it could go a little bit above that, which is probably why it's clipping. And then we do a 1 to 2 non-inverting amplifier, which I don't think I'm really seeing a lot out of for some reason. And I've got the same value components in there. So like, this isn't really doing much. You can see it just wiggles, it wiggles a piece of the wave. I don't know what's going on there. Is it the MCP 6002 not functioning? This is a very high frequency wave, by the way. This is coming in way faster. I just wanted to see what the high frequency element was like. Then it's supposed to get a low pass filter on it as well. So if I put on the low pass filter and I activate it, then instead our output path is going to a completely different structure. Let's pull that all the way over. Let's just see it go through the low pass. I'll need two very long lines. Where is that? Well, that's grounded for some reason. So we're going from here. Let's just do it like this. This is going to go quite a distance, so there might be a little bit of weirdness. Output is this one. That. And then on the other side of our filter, oops, over here. Other side of the filter over to this one. Actually, this is a good argument to use a one of the actual like vertical jumpers. Like that. And now we have our output through the low pass filter while the low pass filter is deactivated. And if I activate the low pass filter, we get a little bit of the wave at the very low frequency. At a very low frequency indeed. But boy, oh boy, there's not a lot going on there. I don't know, I feel like the performance of this filter is not exactly what I was looking for. As long as I still have at least one PWM GPIO pin free, I'm good. The LEDs are all WS2812Bs, so they just need one data pin. Look, man, the amount of screens and LEDs that Cluck J has been able to get running on one of those things is legendary. So yeah, you will have plenty of available output to run stuff. That's what a Raspberry Pi is really good at, is just running external things. Genuinely good at. So I don't know what's going on here. This seems like way too sensitive. Let's get out of sweep mode. Continuous wave. How did I select that last time? I hit one of the buttons. Okay, here we go. So here's a 500 hertz sine. And we can get that into where we can actually view the thing. That looks a lot better. I guess just not sweeping was the key. And I'm getting from 1 to 2. 1 to 2. And we are at 2.5 volts peak to peak. So this saturates at 3? That seems like a little bit much. But we are running it in AC mode. 2.5 volts. This should be at 5. Let me put this to, could it be that Arduino slowness makes up for what the filter leaves on the table? I don't know about that. I think the filter is actually doing work. it's keeping higher frequencies from getting in, and we could barely see that, but we did see a little bit of evidence of that. It might be better to do this on like a spectrum analyzer. Put white noise into it and then look at the output on a spectrum analyzer and see what we get. Because then we'd see a nice chart. And I can do that. I just don't have everything hooked up right now to get that correct. Unless I have white noise on this thing. Waveform. Square. Wow, that is a punished square. That is a very punished square. I could saturate it and make it better. Triangle's looking a little busted. Sawtooth is weird. Steps. Those are some wonky steps. I'd fall down those stairs. I would fall down those stairs. Especially those. I don't know what this one is. I don't forget what we did with this. We did some weird thing. But yeah, there's our sine wave. It looks okay. What I don't like is that I'm at 2.5 volt peak to peak. So if I turn the amplitude up to 10 volts. Oh, this thing only goes up to 5? 10 volt. There we go. Yeah, if we go up to 10 volts, we saturate. What about a 100K pot? What about the bus? That. This guy over. All right, so now we got a 100K. No, still. I mean, the MCP 6002 is doing its job. It's protecting our circuit from the horrors. But it's like, we can't, why can't we go above that voltage? Because it does appear to be centering it properly for 3 volt output. Yeah, we got 0 to 3 point something. Looks like a little bit above 3.3. But something is keeping us from... This thing should have 10 and 10. But if it's 10 and 100, then what are we looking at? We're looking at a non-inverting op amp. And the equation is... Where is this? This is not the right one. Try to get rid of the stuff I don't need here. And get... No, we don't need that. What is this? This is mutable instruments. We'll keep that up. 1 plus R1 over R2. In this case, R1, 100 over 10. I don't know how to math. I don't know why I can't. Doing math on stream is very difficult. 100 over 10 is, what, 10? Yeah, it's 10. 100 over 10, so we had 1 plus 10. So we would be amplifying by a factor of 11. We want it to go below that, though. I want it to go below that, but I don't think I can. I don't think I can make that into a fraction unless... But then it goes to 0, so it would be... it could be like 0.0001 over 10. And if that's the case... Yeah, it should reduce it to 0. Yeah, because when we get the fractions of resistance, which is, I guess, where a logarithmic pot would probably make more sense. But in practice, we can't get to those sub-ohms. There's still just a little bit of, like, the properties of everything are still in place there. Even if I short it out with tweezers. I think the resistance of the wire is affecting. Hey, Cosmo Quest X! Cosmo Quest X! How you guys doing? Rating of the party at 10. Hey, we got a couple raids today. It's great. More feedback will lower the output from a higher value resistor. More feedback. So if R2 is smaller, No. Bigger? If I have 100 Ks there, then it'll be like 1 over 100. So let's get 100K. If I'm thinking about this correctly, correct me if I'm wrong, please, because I know a bit of this stuff. But man, I'm not out of my element here. I'm learning. How's it going? How's everything going over there? Anything going on in space, or is it just boring? Thousands of years, nothing happening in space. Hey, welcome to Cosmo Quest. Nothing is happening at all. Space is really boring. No, it's not. It's not. Everybody go watch Cosmo Quest X, please. 100K. Yeah, right. That's what I was doing. 100K. I'm also constantly battling ADHD. I could put a 1M and then blow this thing up. It wouldn't. It would just saturate. But let's see. Oh, here's 150. I'll put in 150 and we'll just see what the response is. I just don't like the response that I'm getting, and I think maybe it's that the swap from 3 to 5 volts, but I catered to it. I did everything that I should have. I finally had time. We're going from the positive to feedback, so I'm going to power down for this. I'm going to grab this one. I'll rebuild it. You know what? I'll measure this just so it goes in easy. My $50 piece of plastic. Can't believe how expensive these things are. You can also 3D print these. I think there's a similar design on Thingiverse, but this is just for bending leads and cutting them to the right length. It's a pretty useful tool, to be honest. I think I actually have 100Ks, and they're, instead of on the little ones, I think it's on a big reel, and all the big reels fell to the floor at my feet. So I don't want to go get it. Welcome to actual electrical engineering, which I don't know if you'll find a lot of on Twitch. Especially not with the viewers. Space is great. AI like and subscribe YouTube buttons are trash. AI? What is that? Huh? Yeah, YouTube is funny because you don't need to really cater to your audience anymore. You just cater to bots. This one's from the plus lead to ground like that. And so I turn us back on. Oh, now it goes from slightly saturated to really saturated. That's with 100K. I can't control it. So I need a smaller resistor. So let's go down to 5. Well, this is with a 0, but that's not going to do anything. So let's do a 5K. Down to 5 kilo ohms for that pull down, which I guess means we put more ground into the signal. So that makes sense that it would do what it do. Do what it do. 8763. All right, 3.9K it is. It's weird that it doesn't do anything. Am I doing something wrong? I mean, I'm putting it through a 100 kilo ohm resistor. Maybe that's part of the problem. Maybe it needs to be a little less than that. This thing is still set up. Yeah, so I'll use that. Bend the leads. I saw a whole thing about programming microcontrollers for space stuff. And where did my lead go? It was really interesting because there's certain things that you're not supposed to do in terms of how you structure your code. There's, you know, like certain kinds of callbacks and stuff like that are not allowed. And you got to handle, what do you call it? Handle variables in particular ways in memory. More feedback will lower the output for a higher value input resistor. Wish the schematic had labels like R2 just for the sake of this stream. Yeah. Well, we deal with weird stuff here, and oftentimes I'm very prickly about getting certain feedback from my audience because I want to make mistakes and showcase how you handle troubleshooting. when you make mistakes. But today, it's totally fine, and all the feedback has been very good. It's been nice. I've got to reorganize these now, just because I flipped that, and a bunch of resistors flew out. God. How annoying. We're going from output? No. Plus, wait a minute. Was something shorting out? Hold on a minute. That might have been the problem. I'm going from there to what? Not output. I'm going to plus, but there was a resistor right there that looks like it would be shorting it out. That might have been what was going on. Might have actually been shorting out this whole time. What in the world's going on here? Wait a minute. This one goes from minus to ground. I think I've been swapping the wrong resistor. Where's the one that was there? It was this one, I believe. Oh boy, my circuit's all wrong. Hold on, I'm turning this off. I'm going to reevaluate what the hell I did. I think I messed up. I think I screwed up, guys. I think I messed up big. I don't know if there's any recovering from this. Huh. Oh, that's right. Okay, so this goes from here to here. So that's our input resistor. This one is pulling it down for our voltage divider. So our input is coming into the positive lead. This thing goes output minus plus. So minus is here. Minus goes out to the potentiometer. Let's rewind. Let me take a look at the circuit again. Yeah, the feedback. So it goes from output to minus, but then minus also goes to ground through the resistor that we're swapping. And I think it might have been shorting out against this lead right here, because that one is part of our voltage divider. So I need to put these in a different spot. So I'm going to kind of cram this in over here. Please forgive him, O great spirit of op-amps. Man, that's a tortured existence. I'm the spirit of op-amps. I represent math. One of the most real quotes I've ever gotten about electrical engineering is that motors are math. They're just math. Now, actually, I'm tempted to put a 10K back in here. This is, I believe that's a 10K. Because now it won't be shorted against that thing. And then I'll move our 2.5 or 1.6 volt up here. We'll put it up here. That's my 1.65. That's the halfway point of 3.3 volts. And there's that one there. So now we know it's not shorting out against anything. It's a little tight in this area of the board, but that should be good. So that comes from minus, from the minus lead. No, this is the plus lead. Wait a minute. Minus lead. Minus lead goes to the potentiometer, comes back on the output, and then we have a 10K to ground, quote unquote, coming from there. This can be ground or it can be 1.6 volts because we're in a 3 volt system. So let's try that one out. Power on. Boom. Saturation. Nope. 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 Let's turn this one back to 10K. I mean, like the Hajiwo circuits are usually really good. I think just the swap to 3.3 volts is what's affecting this one so badly. Oh, I lost my reference. Hold on, move that out. Let's go over here. My God, I'm like, my leads are all over the place. I'm losing control. I'm losing control of everything. Damn it. So, other pot. And other pot. Feedback. Done. 2.5 volts. There. And then this one is with a 10K. That still doesn't seem to do anything. So now I need to put a much larger resistor on this thing. I'll go back to the 100K pot since it'll cover the values of the other one anyway. It'll also stay out of my way. This has gone south, this whole facet of the project. I was supposed to hook this whole thing up and get a nice reliable voltage source, or rather reliable scaling and you know, trimming of the input voltage, and then I would be able to use the lessons learned and apply that to the other ones. But I'm not able to do fractions very well with this. So from here to, oop, almost lost it, to here. Yeah, it's still not reducing it. Maybe just a potentiometer on the input so you always have a level. Yeah, I mean there's that, but it shouldn't, I don't know, maybe that is the solution. But like this gain knob should go from 1 to 2, right? And currently we have, I mean it's not even a 5 volt. Okay, what's the scale on this one? Okay, it is a 5 volt to 5 volt peak to peak in this thing. This little multi-frequency generator is goodbye. That was a good purchase. And then on this one, we have 0 to 3.3, which is exactly how it should go down. I want this to scale from fractions to double. And it's not doing that. And so let's try another value for this one here. I forget which one this is anyway. I should probably measure it. I feel like something's wrong. Like something is wrong with what I'm doing. So one of the principles is wrong. We went down to 500 hertz because we're dealing with audio frequencies, and the frequency sweep was misrepresenting the voltages present. There was a third LED, and I don't know what happened to it. Did it fall down? Go boom. Did it go boom boom? Well, if it fell, I'm never going to find it again. Hold on, let me get these off the floor. Oh, there's my pin tool. What also fell on the ground. Nobody's been doing the exclamation point drop. So if it's 100-100, then it's not going to be pulling down to ground very hard, and it'll be amplifying. But if we have a larger value, then, so 100, I mean, I've got 100 Ks right here, but so what if I put a 390 ohm resistor in there, just because it happens to be sitting right here? So 390 ohms from here to here. So we're pulling it to reference voltage. Whoa, okay. So there's like zero granularity there. You get a little bit of adjustment right there. Just a little bit. And probably if I give it an amplitude of like 1 volt. Whoa. Yeah, it very quickly goes into saturation, but there's an actual adjustment. It's not very good. The 10K would give me a little bit more ability to, this is barely anything. So that's with a 300, well, with a much smaller input signal. So maybe my voltage divider needs to be a lot larger. Ah, my elbow! What the hell's going on with my elbow? I get stretched before doing these streams. So, I mean, is it the voltage divider not being aggressive enough? If I go back to 10K and I go back, let me revert this and then work on that voltage divider a little bit, because we're supposed to have a maximum of 5 volts peak to peak into the system, after which it would saturate. And you can see up to 10 volts on a modular synthesizer, but you don't necessarily have to work with that. What happened to my resistors? Where's this one? This one is 10K. All right, so 10K is going in here. Poke that one out. Poke this one in. Oops, that. What the? I didn't do anything. I didn't do anything. Oh, that gives me a bunch more adjustment, actually. Wow. Yeah, the 10100 gives me a whole lot more adjustment. Is the 47K on the input connection to plus or ground? We have a 20K, and it goes to our virtual ground, which can be 2.5 volts or it can be 0. That's this one here. And that one's 20K. So we have 1020 coming in order to scale it down to 3 volts, which we did via the resistor divider calculator, because I can't do math on stream. I embarrass myself. Everybody goes, hee bother, you can't even do math. And it's like, fuck you. So instead I use a calculator. But so with 5 volts going in and a 22K going to ground, we get 3.4 volts. And that's what we're doubling or having or whatever. So I feel like maybe I need to go even further into that and just lower it even greater. But I guess the whole purpose of this is to amplify in the way that it is, though. Yeah. Well, math and being entertaining at the same time. I have newfound respect for all of my high school math teachers. I can't see what I'm doing. By virtue of the fact that we are using prototyping board, we are able to reconfigure this thing on the fly, and any of my mistakes become assets. Or what? No, they become undoable very easily, which is the wonderful part about prototyping board. See, this is a 1 volt signal. It's hard for it to saturate. If we go to a 5 volt peak to peak signal, so I go to amplitude here and I enter 10 and I hit enter, I hit volts on it, it goes to 10 volt. Can we even display that? No. So we need to divide it. We need to divide it. We need to divide it to the okay, brain. Let's work with our mouth and work a little slower. What we need to do is we need to get it so that I can barely get this thing all the way over to in one direction, and we can still see a wave, and it doesn't sat. Why is that going above 3 volts? Why? Okay. So, okay, we need to adjust that voltage divider in order to get the proper things. And then I need to figure out how we're going to do this with mutable instrument style circuits. And I don't want to have, I want to have it as simple as the Hajiwo display. The push for me to do this is to also make it nice for Julian. My buddy Julian is going to use this. It has to be nice. So, okay, so we need a smaller resistor. 20K gives us 3.3. So the next one in line, without me going into a different collection of resistors, is, well, 15. That's a jump. 15 is a jump. We can combine stuff in order to make the proper resistor, though. I'm hot as fuck on thermal cam. The cool thing about thermals, and I wish I had a portable thing with the lepton sensor in it, because when I get blood extracted, because I have too much iron in my blood, like, it would be functional for them to be able to see where the big guys are, the big veins are. It's crazy. My scope has a different fan in it, so it's actually a little bit hotter than it should be. Let me get two 10Ks. One of these is a 10K. Or no, we put the 10K back in, so these are not 10Ks. I need to make 20 kilo ohms. The thermal camera is a nice little additive, and it's mainly there just because it looks cool and people can get an idea of what kind of temperatures are running around when I'm like soldering. But there have been times when my test leads shorted out and you could suddenly see the test leads on the desk. So there've been some pretty shocking things. The only clip that I've had go viral, I actually had 70,000 people view it in like a week, was when I blew up a capacitor and I gave it way too many volts. And in doing so, you could see the capacitor heating up as things progressed. And then suddenly it popped off when the dielectric boiled. Usually they're not supposed to pop off and put cardboard into every surface of your shop. Usually they're supposed to just kind of outgas. But if you flash boil that liquid, you then boil everything in your shop, basically. Where did my resistor go? Oh, there it is. I've had trouble holding on to things with this. All right, this is going to send the signal into chaos. That offset it a little bit. Oh, that's interesting. As a stud finder? How? How's that work? That seems a little nonsensical to me. All right, now I need my 10Ks. So we're changing this one to ground as 10K, as 20K. That's a 1K. 1Ks are useful for running LEDs on prototyping boards. 1 and 10K are really good for LEDs because you don't want to have the full brightness. You can calculate the maximum amount of current that you want to get out of your LED, and you can cater to that, and everybody will be super happy at all the cool LEDs you put on your thing. But then when it comes time to actually use the device that you're building, you will blow out your retina. So it always is good to prototype using big resistors on those LEDs. Unless you're going to control it with PWM, but a lot of the times people don't. And for a while, it was blue LED equals future. Wow, that's so futuristic. It's got a blue LED on it. And they would always overdo the blue LED. They'd run it to its maximum current. That's only useful when you have like a PWM system where you're going to have to, where it would dim while blinking super, whatever. Anyway, you always sit in a dark room with your device and figure out what LEDs you're going to be or what resistors you're going to be putting on the LEDs. I need to do that with the modular synthesizer. The only problem is to get to some of those resistors, I need to fully disassemble the modules. So at one point, we actually put a potentiometer on the perforated. This is not working out. We put a potentiometer on the perforated prototyping board, and we then measured the potentiometer's value where the I'm losing my cool. Losing my cool. There was this pair of tweezers that came with one of these breadboarding kits, and it was so much easier to use. Maybe I need to get forceps. Maybe that'll do it. See, that's skipping two things, and then this one skips one. So if I could move that over one, it would be very useful to me. And I guess I can. I'm doing this with the circuit live. This is a major faux pas. It's a huge fupa. But since we're kind of in safe voltage territory, we've got 3 volts running. We've got 3 volts saturation on this thing. I can get away with this. So now I need to bend these leads down. Thermal bridges, like what? You can see the... Okay, let's see what this does. So now we get this one there. Is that one 10? I don't know if that one's 10. Might be a little bit off. Why is nothing affecting my circuit? That one's in there. So 20K. Power's on. Oh God, it got worse. Wait a second, what happened here? What have I done? Is this clipped? This is clipped. This is clipped. Okay. Everybody's clipped in. This is my 2.5 volt offset. What the? Is this not 10K? Hold on, let me check this one. This one looks different than the other 10K that I just got. Maybe I need to get a new, I'm going to get a new 10K on this. I'm going to get a new 10K because it doesn't appear to have done anything. What the hell? Those leads are very strange. Okay, so let's get an actual new 10K resistor. Oh, that wasn't 10K. That wasn't the one that I got at all. Whatever. I'm getting confused. These things don't have values written on them. I like my surface mount stuff. We could have done this with soldering and surface mount. But then I guess we wouldn't have been able to test these circuits so easily. There's also PCBs that you can get that have op-amp circuit stuff that you can just swap in. I should probably get one of those. Why is this so busted? Wait a minute. Going in here through a 10K, and then we've got this configured in a 20K. All it does is saturate. Sucks. Happy Friday from Australia. What's going on? Oh, it's R1M Dog 78. So Rim Dog Tiba. Well, Rim Dog at least I get. How's it going? So we're building another Hajiwo circuit, and it's the same one we've been working on, but this time I'm actually building the circuit. And so we're looking to see how in the world I am supposed to be getting this thing properly biased. And we're changing it to 3.3 volts from 5 volts. So the values of stuff change. But in addition to that, it's like I adjust this thing and I'm not really getting, I'm just getting like saturated out of the whole thing. So what I'm trying to do is adjust the input voltage divider in order to give us the proper signal. We've got a 10K and a 20K resistor on there. When we go above 20K, what happens? That gives us too many volts. What if I put a 10K in there? If I just went straight over with a 10K? Let's try that. So these two out. I'm gonna just take this 10K and I'll just whip it in there and just see what happens. Excuse me, can you please? You son of a bitch. Okay, let's do that. Bend it down a little bit. Ah, these leads are messing with me. So yeah, from our 2.5 volt offset. Sorry, it's actually 1.6 volt offset, half of 3 volts to that pin there, and that it's looking a little better, isn't it? We need it to be just a little bit. Well, are we going below 10K? Is that really what's going to happen? I guess we are. So below 10K, what do we have? 8K, 8.2. Let's see what that does. I guess we have to lower this significantly so that the 1 to 2 thing actually works. The gain circuit works. We're at 5 volt peak to peak right now. So with 5 volt peak to peak, we need to make this the maximum saturation at one end of the adjustment. That way we will be calibrated in that direction. So from here, I could probably move this to the other potentiometer and we could just figure out what the value should be. Maybe that's the way we do it. Yeah, let me route it to the other potentiometer. We're on a breadboard after all. What am I doing? What am I doing? I could have solved this easily. So if I just take 2 more of these, and I go from this one here. This is where those rat's nest setups come in handy, where you have wires everywhere. So they're all going vertical, so nothing's interfering. Ugh, this is gonna pull out too easily. Terrible pull-out game. Okay, so now I can adjust. Yeah, there it is. So that's the ideal value right there. I have no idea what you're doing, but I find it fascinating to watch while I have my coffee before work. Man, time zones are a beast, aren't they? That's crazy to think of. There were times when my cousin would join in. I think I already told you this story the last time you joined. My cousin would join in, and he's in Australia as well. It would be 4 o'clock in the morning, like 3 or 4 o'clock in the morning. So he would be drunk. I have to deal with his drunk ass. It's in the middle of the afternoon here, by the way. It's 3:30. So now we have our ideal value. I can turn this off. What I'm doing is, so this circuit has a couple principal things that it does. In electrical engineering, when you have a voltage divider, what you have is you have a resistor going to positive and a resistor going to negative, and those will pull your voltage value in either direction. So mathematically, the ratio of those two resistors, as shown by that equation over there, you don't have to worry about the equation. You just have to know that it will basically divide your voltage by a certain coefficient. So if you have the same value on both, it'll pull it evenly in both directions and have your voltage, right? So what we're doing is we're determining what that voltage divider value, what the ideal value of it would be in order to give us saturation, almost saturated, well, to give us the maximum visible wave at the maximum voltage that we are catering towards with this display module. So we want to be able to view a positive to negative 5 volt swing, no more, no less, even though sometimes there are greater value signals. Wait, these messages didn't come through. Oh no, the thermal bridges, okay. That's what we're trying to do, right? And so I'm looking at the circuit from Hajiwo, and we've sort of reverse engineered, even though there's an explanation on Hajiwo's website, I had to reverse engineer it so I understand it. What's happening is here's a voltage divider, right? We've got our positive signal coming in here, our positive voltage coming in here, and that can vary, but it's maximum of 5 volts. So then we put it through a voltage divider, and apparently the values that I was choosing weren't exactly correct. We also need it to be offset by half of the display voltage. So that's sort of what's going on here is I've got a 2.5 volt signal going in here. I need the potential on the outset here to be, yeah, anyway. But then we're putting it through an MCP 6004, which is an operational amplifier. These two diodes right here are just protecting the rest of the circuit. They're not necessary because the MCP 6004 should not be seeing all that much voltage. I don't know whether or not it'll explode. What can the MCP 6004 actually take? How tough is this chip? Sorry, it's a little bit of a sidetrack, but I just want to see what this thing can take. Maximum input. Maximum armor. Input offset. Power supply rejection ratio. Input bias. Common mode. Where's my maximum output voltage swing? What's my maximum input voltage? Noise, 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 temperature, thermal resistance. I don't know if we've got such a clear maximum input voltage. Supply voltage, 1.8 to 6. Yeah, they're all, I don't care about power supply, I care about input voltages. How much can they exceed? It's probably in here somewhere. It's just going to be a, just going to be dug in. Oh, analog inputs. VSS minus 1 volt, VDD plus. So that can only go to 4 volts maximum unless this thing gets damaged, which could be a problem. We're not going to implement the Hajiwo circuit though. I'm going to implement a different circuit. But how do you limit those voltages? I guess that's why the Schottky diode barrier is here. So you put this thing in here and you give it your positive voltage and you give it ground, and then it doesn't allow it to exceed positive voltage to ground. So that'll keep you from blowing up your chip. Maybe I do actually implement this exact circuit fully. But yeah, then we have a non-inverting operational amplifier. Op amps are weird. The input is compared on the two ends and then output over here. So if you have it go in through the negative, you can feed it back so it'll cancel itself out. I don't know what the hell's going on in a non-inverting, but it's 1 plus your gain equation. So it's basically just math. And so right now I've got this implemented directly, which should be a 1 to 2. It'll go from a 1 gain to a 2 gain. So either you multiply the output by 1, or sorry, the input by 1 to get the output, or you multiply it by 2. So I'm able to actually double the signal in order to view it on the scope. Right now, we have the maximum voltage that I'm willing to cater for going into this thing, which is positive, negative 5 volts. And then, of course, it is doubleable, although that doesn't seem to be double, to be honest. We need to figure out what the value for that resistor is. So I'm going to power down, unhook my pot, and measure it. I don't have any more space on the screen for anything else. I don't want to make this super small because it's a very, very pretty display. I don't know how small I can make things and you guys still tolerate it. I certainly could get back a lot of real estate on screen. 5K, believe it or not. I'll prove it to you. Okay, all right, 5K, there you go. Almost exactly 5K. That's nice that it's a round number. Now, my resistors are probably not going to be a round number. So it's going to be 10 and 5 are apparently the ideal values for getting a positive 5-volt signal into your 5-volt peak to 10-volt peak to peak, positive 5-volt signal. Jeez. through a thingamajig, through a oh God, my brain does not work today, guys. It just doesn't work. There's 8K, here's 3K, here's 5.6. 5.6 and 6.8. So ideally, well, let me note down 5K. I wonder why that is. If I put 5.6 in there, it is going to slightly saturate. If I put 3.9, that's more towards 4K than it is the other way around. Or I could put two 10Ks in series. Or, sorry, in parallel. Parallel. Maybe I will do that, actually. Yeah, two 10s in parallel. Let's do that. I just need to make sure that my 10s are 10s. That one's 10. Cut these leads to length. That goes from here. Oh, that actually has to go pretty far. That has to go pretty far. Well, I could bring it in a little bit, actually. Let me do that. Bring it in. I'm doing this live, which is not really recommended. Both live streaming and actually messing with your circuit while it's on. Any meaning you can glean from both of those. Ow! What the heck? Why did that... it's like stuck out of my finger, just this cut lead. What the hell? It stuck out in such a way to be like a little doorstop, a little hood prop directly into the side of my finger. That was annoying. Man, we got to take a break from this and do like RC cars or something soon. Okay, bud, can you just, buddy, please? I think I need forceps to work on these things because they'll grip a little bit better. No, these are curved. I can't deal with that. Nope, too unfamiliar. There you go. So there's that, and then I'm going to put another one in. What are you? I don't think this one is going to be 10. That's 8. We're not quite feeling 8 today. We're more of 10. We're 10 gang in here. I think another one of these is 10. Eight? That's the one I just put down. What is this one? No, this one's not 10. 389. What are you? You are... I may just get a new 10K. Sounds 21... Wait, 21K? Huh. That one got really close to 20K. I didn't even know I had that. Love anything RC. I've been flying RC planes for years and just started flying them FPV. FPV is an amazing experience. I have everything that I would need to do that, and I've been getting into 1/24th RC cars, which are very small. You can just like put them in your pocket. And right now, this thing has way too powerful of a motor on it. And so I've been playing with designing aero for a front and rear spoiler on it. The camera cannot handle the color red, so it blows it way up in saturation. But this thing is pretty cool. Like I bought an expensive kit. This is the Atom SC2 all-wheel drive touring car kit because I had a lot of fun with the WL Toys stuff. WL Toys has a model called the, I think like 989. There's a couple different numbers of it, and it requires a lot of tune-ups in order for it to work properly. But then you get this tiny little RC car. It's really fun. This thing is way too fast. Like, every time I take it out, I don't discharge the battery. I end up breaking the model, which is fine for me because fixing it is more fun than actually running it. But because I look like a sentient beach ball with an RC controller in my hand. I don't really want to be seen while I'm doing this, so the sessions are short. Yeah, this one I've made brushless. Originally, we were supposed to be replacing the Mario Kart home circuit cart and doing advanced cheating and making it work with the sort of the DC motors. But that never really came to fruition. I was going to send one to Djibouti's show because they were doing the Mario Kart home circuit stuff. That was years ago. It was like 3 years ago. And I got too deep into it and I never actually like produced something. It would have been better if I just made something that they could play with instead of you know, tinkering with it endlessly. I'm gonna get a new 10K. Those are right here. That one will go in parallel with the other 10K. Will give us 5K. Miraculously. He's a witch. Burn him at the stake. Electrons don't make sound. What is this witchcraft? Yeah, I'm hoping with all that aero, I'll be able to actually control it at the high speeds. Maybe it won't blow up immediately. It won't crash and explode. But then it would be fun to be able to get that the Mario Kart home circuit to go that fast. And then I can get a little clip of it. Maybe it'll go viral. Probably not. Nothing I do goes viral. That beautiful viral thing where everybody's suddenly watching you. You get all this attention. Why no output? Wait, what's going on here? Who died? Oh, output's off. Turn it on. Boop. Oh my God, that's not what the 5K is supposed to do. Dear God. Did it go below? Or am I not? Oh, wait, hold on. What isn't happening here? There's our reference. Get rid of that, and everything goes crazy. Oh, wait a minute. Why are 3 things on this line? Hold on a second. No, that's correct, because this should become... Oh, it's on the wrong. Wrong lead. Well, that's going to be a challenge. I don't know where I can pick up on that on this one. I guess I could just double it up. Does that even work? All right, there. Equivalent 5K. We're saturated at 5 volt peak to peak. And then I can double it up if I need to. I don't know if that's double. I don't think that's quite double. But then if we go to, I mean, I guess if we go to 5 volt peak to peak, amplitude 5. So this is 2.5 volts peak to peak. And if I take it a little bit above that, so if I do 6 volt peak to peak, amplitude 6 volt, it clips a little bit. Yeah, we're perfect. Amplitude 5 volts peak to peak. That's turned all the way up. So that'll come in like that, but it can also go in like that. And that is, of course, 3 volts, 3.3 volts and 0 volts. So that is functioning correctly. We have an AC wave coming in. We are putting it through a capacitor, which is getting rid of the AC component. So it shifts it. And then we're doing all of our comparator work from 2.5 volts. And that's the Hajiwo John. So now, if I take away that ground, or the 2.5 volts, and I hit it up with ground, need to find a ground. Now it's only taking the positive component of that wave. Only the positive component of that wave. But if I offset this by 2.5 volts, why does this thing never take 2.5 volt? No, why is it still... Oh, because the capacitor's in there. Doink. So there would be a switch on the front panel that would allow you to delete the capacitor. And so if I capacitor delete, I can see my whole damn waveform. Okay, so we have implemented Hajiwo's circuit. that was a pain in the butt. We've implemented Hajiwo's circuit, and now that can communicate with the microcontroller. Now, there's no possibility of this thing oversaturating, but there is a possibility of this circuit overdoing it for the MCP 6004. If I involve another op amp, and I could even put it in like normal saturation, it's possible that I could then make it 10 volt compatible, because you see up to 10 volts in a modular synthesizer. This thing, I believe, would blow up the MCP 6004 if it saw 10 volts, because the 10 volts, it's going through a voltage divider, and the voltage divider goes directly output. So like if our input, where's that calculator? You like, oh, no, get away. It's in this tab. So we're actually running a 5. Why did you change that? 5K. Why are you fighting me? That's weird though. 1.67 from 5 volts. If we go to 10 volts, we get 3.3. But why? But then that doesn't apply to. Hold on a second. 10 volts, 10 and 5, 3.3. We have 1.65 volts on our offset if we wanted to do AC, but then here we are getting a swing from for input. That's channel 3. A swing from, that's a little bit more than 5 actually, according to the scope. We're not even like, this is not half of between 4 and 5. That's a little bit higher than that. And yet, let's measure something. Let's put a probe down. We look at, first of all, our input is there. Oops, let's get that. That, okay, there's our input. And then it goes into the voltage divider here, and it becomes 0 to 3. In spite of the fact that, like, is my 10K not a 10K? Because apparently, according to the calculations, it's supposed to be way less. Whoa, what just happened there? Stuff is unplugging itself. According to the calculation on the other side of the voltage divider, we're supposed to get, if that's 5 volts, we're supposed to be getting 9 volts. This thing is not in 10 mode, it's in 1x mode. And if I measure it on the input right here, oh no, that's just the input. Here's the voltage divider. We get 3 volts. Why is that? I've doubled the input. And yet, for some reason, it's like this. Is it not strictly operating like a voltage divider? Is that what's going on? Or is my ground have a little offset? Just noise. Just noise, normal stuff. Noise. Just normal circuit stuff, huh? Normal kind of stuff, nothing crazy. Just kind of like circuit stuff. Wait, why am I not getting anything there? Wait, you're getting something here. Oh no, this is ground. That's right. Okay, yeah. This is the other side of ground. Other side of ground. Negative input. Positive input. Both the same. Weird. Got a doubling effect? I don't know. That's very strange. How's it going? Good. What the hell is that about? I actually added an emote, but nobody likes to use my emotes, so whatever. Polave Jam. What did I added an actual emote. I added the heart finally. We have that one. And then I think the other one that I added, I added the driving emote, I thought. Where is that? Why is it not in here? Oh, what? Wait a minute. There he is. Well, driving emote. Polave. I don't know who Polave is. Wait, if I say emote, does that emote start? Emoji, emoticon. No. I saw little hearts appearing above the emote thing on YouTube. What is going on? Here, over here, there's a lot of stuff on screen, but like over here, the little hearts started coming up out of this. I don't know if it's just doing that throughout the day or if my saying emote is setting this off. Google's doing some weird stuff with their AI and listening in on me. Maybe it just does that throughout the day. That's me. What are you doing in the background? Okay, so the math isn't mathing to me. I don't know why. For some reason, 5K should be having half of the effect that it's having. And it's something, it's probably me. I probably don't understand something that's going on with the circuit. Because, I mean, it's our power's coming in, and this could not be more clear of a voltage divider right here. So between the 10K and the 5K, which is just two 10Ks, that's definitely a 10. How is it that on the outset of that, and the op amp is supposed to be high Z, so it shouldn't be doing anything to affect it. The input signal goes from ground. Actually, right now, everybody is going from ground. I turn this into the AC couple, or the DC mode. So I turn, there's no capacitor in there, and the reference is to 0, which is ground, which is the same reference as our input voltage. Huh. So Hajiwa's example says, looks like that. 2.5 through the amplifier, looks like that, or it looks like that. What if we 2.5 this thing? Well, it'll saturate. Oh no, it'll just look like that. That's kind of cool. Yeah, it's just like his example. I mean, I guess it's successful, right? This is the way it is. Under the scheme that we've got, if it's 10 volts coming in, that's going to come out as 3.3 maximum, although it's going to be way less than that for us. And right now we are 5 volts offset 2.5, so this is 0 to 5 on the input. And if we go to 10 volts, it'll go to 3.3. But where is this one at? This one is it goes up to 3.3, and it's offset by 1.65. And I can turn it back to ground like that. And now it's 0 to a little bit below 3.3. There. It's a 0 to 3 volts. And I think that's just because this doesn't quite go to the rails. And it'll saturate if there's any more than positive 5 volts. Okay, so we've figured out the Hajiwo circuit. The question is, how can we make it? Time to go to work. All right, hey, thanks for dropping in. I'm glad you're engaged with this kind of stuff, because it's blowing my brain apart, and I'm trying to figure it out. Now, you guys have been awesome today. Very good crowd. I'm just wondering what the hell I need to do here. So ours, by the way, ours isn't 1.6. It's it's not 2.5. It's 1.65, because that's half of 3.3. But we're getting the performance that we want out of this thing, and we now know what that looks like, right? We know what the good performance looks like. Now, in my pursuit of this circuit, I was operating with it like this, which isn't quite the way that it should operate. But I was going into an inverting amplifier. This is just an example of a mutable as instruments type thing. And then I came up with this scheme, which is a little bit more complicated, but in order to make, what do you call it? In order to make this thing work, I mean, would you turn on and off the -10 in order to get rid of that offset? Because plus minus 5. So it's pretty clear what I need on the outset of this. +5 and 0. So I need, or no, it's not +5, it's plus 3.3. And I need 1.65. It needs to be like this, or no. With the thing adjusted all the way to one side. So knob at one side. Plus minus 5 volts. So what is that circuit going to look like in the end? I mean, this is just amplifier stuff, right? We should be able to do that. It's okay if it's inverted. We can invert it, and we can revert it in code, right? And I wanted to put it into a mutable instrument style circuit. What mutable instrument does is they apply a -10 volt input that's biased. So it's 2 to 333, and then the input is plus minus 5, so +5 to, it's 1/3, right? So this one's 2/3 and the other one's 1/3. 2/3 of 10, 1/3 of 5. This is strange. In the math, though, it comes out in the end to be 1.65 plus or minus 1.65 volt, right? So that scales that way. But if I wanted to add a capacitor in there, so I wouldn't need any of this stuff. Instead, I would need to offset this thing by a certain amount because it's now centered, or no, it's now offset. But then wouldn't we get 10 volts in and that would blow up my equipment? 1 second, let me think about this. So if that goes to not 2.5. And that would be only on the plus, that wouldn't be on the reference for the op amp, ground or 1.65. Or would it have to be -1.65? Plus, minus, question mark. Would it have to be -1.65? So 0 to 3.3 volts is our goal from plus minus 5 volts, or it would be 0, it would be or 0 to 5. But this works for the entire range plus and minus. So I would be putting it through this, and it would come out as a perfect 0 to 3.3 volts over here. But if I put in, well, maybe we should just build it. Not sure if that works with just a voltage divider. Right now, this circuit kind of works. You know, I've got a representation of this circuit. It's just, I want it to be in saturation when I'm at positive 5 volts input. Or rather, it would be negative at positive 5. At -5, it should be at saturation at 3.3 volts, which this accomplishes, but without the before adding an adjustment in there. That's what this accomplishes. So that would be with the knob all the way in one end. Would the potentiometer have to be on this? So if I put this together, let's just see. Let's just try to get similar performance out of this thing. So we have most of that circuit built. I just need to measure a couple things and you know, put some jumpers here and there. I turn that off, and then I'm going to, I don't think I have anything longer than the red wire, so I guess this red wire is going to be in our way the whole time. You just tuck that in over there. Okay, so with that there, I'm actually going to put another jumper in here on our 2.5 volt offset thing, and I'll take this over here where we can apply it to the actually, well, I just jump over to the positive pin. Yeah, I don't know. Let's just see. Let's see what I can come up with here. So we'll take that and we'll put it to the positive here, which is, I need to pull up the pin out. Scroll all the way up. So positive's at the very end of this. Where are my jumpers? What did I do with a little bin of jumper? Oh, it's way over here. Why did I move that so far over? Not like this is what we're working on today. Jumpers. Let's see. I can probably get away with a red jumper on this one. So we'll take that from here. Jeez, this red wire is really getting in the way. I'm going to unplug this for now. Here, down and over, and we're just going to tap into the 2.5 volt line over here. This way I can do a direct comparison between the two. I'll have to do a clip lead to the one, but that's fine. So that's our 2.5 volts. That's going into the positive comparator. The negative comparator over here also needs to go through a 200 kilo ohm to the negative 10 volt source. So here's 100 kilo ohms, and then here's another 100 kilo ohms, and that goes here, and then the other one goes through a 100 kilo ohms, and it goes to our input signal, which is this line right here, and this line right here. So there's our input signal going down to there, into our other circuit, which will later become a capacitor, but for now, this comes and goes through the 100K, and it goes into our MCP 6004. Let's see, the capacitor we're not doing at the moment. And then the rest of this is coming from, that's 3 volts for the power. And then our output is here. That should get a 33 kilo ohm to here. And that was a surface mount resistor. So let's find that 33. Well, we could just put that through the potentiometers, actually. And we can have a 100 kilo ohm variance between there, just to see if we can get a comparison between these two. So from here, I'm going to go all the way to the 100K. Of course, we're probably going to need more adjustments, but we'll find a happy place with this. Okay, and then we'll get another one of these things. All right there. That one goes in with all these bubbies right here. Okay, so now this whole circuit has been implemented, and I can clip in to the output, which I'll just need a lead for. Clip into the output, or just something felt like it came undone. I guess this one's not going to get the benefit of that low-pass filter. Just do this right here, and we'll clip the lead onto that. And then this one goes all the way to our actual scope output. There's that. And then we can hook up this. Where's my scope hat? There it is. You got to be real careful with these scope hats. These things will run away from you. You'll never find them again. They are worth their weight in gold. All right, so now both circuits at once. Go. That's unique. Well, that's unique. That's kind of unique. What's going on there? Why is that happening? Wait a minute. What the fuck? It's like saturating at 2 volts. If I do that one to ground, maybe that one has to be to ground. Oh wait, right now it's nothing is going in there. Now it has ground. It's still saturating it. What voltage is that? I can't see because that thing's covering it. Well, 4 volts. What the? Saturating at 4 volts. This is a 100 kilo ohm potentiometer, and it's on the feedback resistor. We have our input signal is 0 to 5 volts. 0 to 5 volts. Oh, and our second output is not doing anything. Why aren't you doing? What are not doing? Why not doing? Where's blue? Is he safe? Oh, I didn't put it to the right pin. There we go. So with, let's see, is everybody on the same scale? No, but these need to be on the same scale. There. There we go. So, okay, we're seeing similar performance out of both of them then. Because that is saturating over the level. Since I've got a 100 kilo ohm here, you know, that's just, it's what it's. So this should be down from here. And I can just figure out what the 2 resistor values are for this. And then set up a couple things in order to make it happen. So I turn this off, and now I can measure between those 2 points. Whoa, what the heck? What is that feedback? Hold on, wait, what the fuck? Wait a minute. What are you doing? that might affect my measurement here. It does not. 375 kilo ohms. So 375. Whoa, hold on. Now, I probably want this thing fully disconnected, so there. Now it's fully disconnected, at least on the circuit end. Here to here. 25K. Okay, 375 was definitely a latent voltage left over. So 26K. 26K on the low end. See, this is so much better than having MS Paint do all the schematic stuff around here is so much better than having like a CAD design or anything else, because it's so much more free. I can take notes on stuff as I go. I would suggest that you guys do the same. I mean, it's much nicer to use this way. So from there to there. And then I turn everybody off, cut this off. $48K approximately, 47.97. So 48K. 26 to 48. Huh, 26 to 48, huh? That's not 10 kilo ohms apart, huh? 27 to 37. That wouldn't quite give me the range that I want. It would be like a 50K, 24. I could do 24 plus a 50K. Well, I'd take 2 ohms from one and give it to the other one, right? And then that would mean that it would probably saturate a little bit. But a little bit of saturation is okay. We just can't give the MCP 6004 a buttload of voltage. Otherwise, it'll die. I'm wondering about this mutable instrument circuit. Like, if something happens to that input and it doesn't go to ground when I unplug it, will it blow up the MCP? Or does it just not work at those voltages? I don't know how that works. Either way, when I plug everything into this, we get the same performance out of both of these. One's just inverted. Whoa, that one's looking a little frumpy. I think something got knocked. Got some frumpy signals. You can see how much cleaner the mutables design is because it's got that nice -10 reference. And actually, this can go all the way down to 0. So if I just put a 48, if I just put a 50K on this, that'll give me a full range, including the smaller values here that I was trying to achieve with the other circuit. Whereas this one only goes down this far, I can get much less fart out of this one. Look at how much farther it goes. Man, my elbow hurts. I must have slept on it funny. I tried to watch Dune last night. I got a totally legal copy of it that totally wasn't my cousin with a camcorder in the theater. I don't know why it's that specific, but anyway, I got a totally legitimate copy, and I went to watch it with headphones on, and it was too cozy, and I fell asleep. It's probably why my elbow's all messed up. I probably slept on it. I like the mutable circuit so much better. Look at this. I get all the way up to my maximum usable range. This one, I mean, I get up to the same like range as that thing, but like this is all the way at the top of 3.3 volts, and we're getting a 5-volt input. So that's it. It's just instead of 33, it's a 50K pot. And that solves it, except now herein lies the rub. What happens when I do the input shaping that the other one did? So I go through and I remove ground. I remove the boy, and then I give it 1.6 volts. And then, just because I'm a silly guy, I put a capacitor on the input. It's kind of hard to implement with this breadboard. It's just the specifics of this setup are a little bit difficult. Like that. The other one gets a cap too. Let me get a cap for the other one. Anybody heating up? No, everybody's fine. So with the DC offset, we did just fine. It's just this one should be performing similarly to the other one. It just killed the circuit, huh? Did I? Oh, I didn't hit my mark. Yes, I did. Input's here. We're moving it over to here, through the capacitor. Then it goes into this. And it just dies. So there's the problem, is I can't do the same thing with the offset voltage with the other circuit. Huh. What if it is negative 1.65? Do we then see it work then? Because yeah, this input is, well, it's offset, but we still should get the same stuff. Yeah, everybody gets caps. Everybody gets capacitors. Offset will do 0 volts. There, so that's what we're getting at here, is that with the AC coupled circuit, we can then offset it and represent it properly. So we've done that in 3 volts, and we've done that for our non-inverting, but our inverting may need to get negative 1.65. So what I'm going to do is I'm going to give it negative 1.65. So the other one's going to go into saturation, and then this one will hopefully bounce back. Get rid of that, and now I get a jumper, another jumper, and I put the negative into the junction. And positive into ground. And that gives us an offset. Very janky, inconsistent offset. Hold on. The Jankotron. Yeah, that's not quite doing it, is it? That ain't right. Whatever's happening there. So how now, brown cow? How do I get... Do I put the 1.65 into the negative input? Do I do it through a 100 kilo ohm resistor? And then it gets the same bias as our plus minus 5. Or do I do it into the output? Because the whole point is that I'm offset. No, it can't go through the output. Probably has to go 100K into the input. We'll try that. Let me get a 100 kilo ohm resistor here. Try that. Let me put this back to ground bias on the comparator. But that's what we were doing with the other one, is we were taking that offset and we were applying it into, well, but that was, I guess it's different because it's got the comparator stuff going on there. Yeah, see, now this suddenly works. Whoa, that's all jacked up. Wait a minute. Oh, because of the capacitor. Wait, what the... What the heck? What is this? What's going on here? I've created a monster. Offset negative stuff with a divider in the same way, but upside down. Still comes out negative, but smaller. Hey, what's up, Clibber? It's been a while. We had some old names coming back in here. Yeah, I mean, I guess like the same, treat the same way. That's so weird. What is going on there? You get some weird stuff. The other one seems perfectly consistent. It's just that it's a little bit strange. Oh, there we go. Now we're back. Did I plug it into negative 12? I must have plugged it into negative 12. So really, it should look like that. But then if I give it the 2.5 volt reference, it doesn't treat it the same way. Not so sure how it works when it crosses 0. Yeah. Although, wait, this should be... Well, it's funny that I'm able to get a perfect wave out of it. It should be inverted, but I thought it should be... No, this is correct. Yeah, this is the way it is. And then I would need that to have an offset. So if I do a 1.6 volt offset from that, I could do it with, let me just try this, possibly not applying it directly. Maybe applying it directly. This is ground to ground. Oh, no, I need it to be negative. So if I hit this ground into 1.6, and then I hit you with my offset. Damn it. Keep losing my clip lead. These clip leads are so annoying. You have to like bend them in a particular way in order to get them to cooperate. Okay, that made a little snapping noise. Maybe I need a resistor on that. Let's get 100K. Where's my 100K? Are you my 100K? No. That's a 1K. There's 100. All the way over here. All right, so going into this here with another source. This one's offsetting it. Killing it. Never mind. What about on output? Nope. So then going to the plus lead, which currently goes to ground, but instead giving it a 100K to the negative supply. Boy, this thing's hard to unplug. There's a lot of stuff, a lot of layers. We were so close. I just need to accomplish the same sort of scaling that the other one has. That almost got it. Actually, I think that does got it. So going through a 100K to negative 1.65 volts, we have offset it so that it's got full swing, -3 to +3, from, well, this is a 2.5 volt sine wave, so I don't know if that's, well, it's 2.5 volts and it's centered on, but then this is only offsetting it, which is not what I wanted. This should be turning it up and down until it's a flat line. So that doesn't quite do what I wanted it to do. Close. It certainly would fool me under these circumstances, but I don't think that's quite right. That needs to scale instead of this. We're already applying a -10 volt reference to it. But if I apply the 1.6 volt, the -1.6 volt, it doesn't offset the ultimate output by 1.6. If I apply it to the negative comparator input, then we are moving our voltage around. Yeah, I mean, I've got this chip going in to the circuit, so I will have access to 2 op amps. Maybe it's possible that I just have a scaling, like a gain circuit, and then a separate input circuit. Basically just do a Hajiwo circuit and then put it into, but like, so I don't know if I understand. How does the other one treat this voltage? Hold on, let's re-implement this the way it was, and we'll get the 3rd channel off here. Whoa, was that running away? Yeah, look at that. Oh, that's kind of cool. I wonder what that sounds like. It probably sounds like a 60 hertz buzz. You can make some pretty random wibbling going on here. What the hell's Vernier? Oh, weird. Blah, 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 blah. Yeah, that's just going to be a 60 hertz buzz with a 500 kilohertz, sorry, 500 hertz tone underneath it. Strange. Okay, so let's see. That's just a floating ground right there, which I can reconnect. Oopsie daisy. All right, let's reconnect that ground and get that stable. There we go. And then this goes to the output over here. It slipped. I don't know why it's looking so jacked up, though. Technically, that shouldn't be cutting off like that. Oh, that's right, because it hasn't gotten that yet. Okay, so here's that. And then if this gets its offset voltage from here, where's my ground lead? There it is. Ground to there, voltage to here. So now that one looks perfectly fine. Perfectly fine and in complete range, and I can take it all the way down to there. And then if I give it 10 volts, it's still within bounds. And then the opposite would be for the other circuit to work, unless I invert it back with another op amp. Because then I wouldn't have to deal with the inversion. If I invert it back with a unity gain op amp, then it would, and I apply that the positive voltage to the inverted one, then I think it would properly offset. So if I did a second one, this would go to another op amp, and it would be inverting. Let me just get rid of some of this stuff. Oh, and I guess I can't draw a sideways triangle. I'll just do it by hand. Boop, boop, boop. Nope. boop, 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 boop. And then not this. Okay, we're gonna have to use special selection tools. Grounder 1.65, and then minus plus. And then we just do a little feedback like that, and that's unity gain. And then that would be oat. So if I did that, all this thing is doing is offsetting. But that's the only place that that 1.65 volts would be necessary. That's a little bit weird, isn't it? So in order to properly, there's got to be a better way to do this then. I mean, a Zener diode, yeah, I can throw a Zener diode in there. And this way I don't have to make a negative volts. No, that still needs to be negative. Oh, no, it doesn't. It doesn't need to be negative. That's right. So what this does is this saves me from having to create a weird negative voltage. So actually, the eraser. Oh, they're starting to do the yard around here, and the dog is going psycho. So that would give us a positive offset for an AC that would then scale it to 3.3 volts, but it's using an entire another op amp. But in this circuit, I have an extra op amp. There's only one channel on this thing. And I don't think I'm about to make it 2-channel, although the RP2040 could probably handle that. But I mean, it would be interesting to make it a 2-channel oscilloscope if I could get this circuit to work properly. But this circuit with the 50K pot, the question is, how do I would have to get a negative 1.65 offset out of this thing. And the best way to do that is to put negative 1.65 into the ground pin. There probably is another clever boy way to do it, though. But I don't think I can do it with a positive voltage. If I set this to offset positively, it's going to end up offsetting it negatively, which it's flipping everybody. So then if I give it that 1.65 already, and we're adding to it, why shouldn't that work? I thought that would work, putting it in there with 100K. Let's try that again. Let me try it again. So somewhere around here, I've got 100 kilo ohms. So this thing's on ohms right now. My meter is just off screen. It would be kind of neat if I got a meter that actually was able to display a value on screen. I think there was, the one was USB. I don't believe that it's 2 mega ohms. There we go. Yeah, this is 100K. So if I take that reference and I put it in, well, that thing's already offset. Put it into here. I think my waveform just got smaller. Oh, that's right. Yeah, so the properties of it completely changed. They're super weird. Instead of amplifying, it's just sort of like offsetting. It's offsetting instead of amplifying, which I don't quite understand. Don't forget the resistor and the feedback if you're building the inverting amplifier. It's unity gain. Let's just look it up. So I think 2 1Ks or something. Blah, blah, blah. That should be unity gain, but I think it's unstable. So you put a 1K on each. The theoretical gain is not. Without the resistor only works for non-inverting? Do they cover that in this? Wait, where is this? Hold on. I'm looking at the web page that I just pulled up. which has disappeared. Did I close it? I must have closed it. Okay, well, anyway, yeah, so 2 1Ks. And then I'll have an inverting amplifier that I can apply a 1.65 volt offset to, a positive 1.65 volts, right to that pin. I mean, I've got access to like up to negative 12 volts, so I could make a negative reference. And if I were going to do that, negative 1.65 should go into there and offset it. The only problem is it doesn't adjust the same. For some reason, it gets a little weird with it when I do that. So if I have a positive to negative and I add a negative 1.65 offset, shouldn't it do the same stuff? But then it doesn't amplify stuff properly. I don't know why that is. Just the weirdness of this thing. Because all it does is like bring it down into the area where it becomes a wave. It doesn't amplify at all like this one does. This one is now offset, and it's as I adjust it here. As I adjust it, you can see the blue trace gets larger and smaller. But if I do the same thing, hold on, what am I doing? I'm getting, yeah, that is what's happening to this right now. So right now I've got it in the configuration that I'm describing, where I've got a positive 1.65 volts going into the ground pin. So the positive 1.65 volts going into the ground pin, the adjustment for some reason suddenly, instead of doing this, which is what the other op amp is doing, it does this. I guess instead of being centered on the offset, it's comparing it to the offset, but that doesn't make any sense. Saturation, desaturation. How's that supposed to work? Is there supposed to be like 0 volts to negative 1.65, or should there be a resistor there? I think we tried it with a resistor. What if I get this and I put a resistor there? All I've got is a stray 100K. Same difference. Yeah, because it's high Z, it's just looking at a reference level. If the reference level is ground, or 6 point whatever, then there you go. There it is underground. I mean, that's going to ground and it's doing just about the same job. How is it doing that? Wait a minute. It's through a 100 ohm resistor to ground, and our signals look exactly the same. Oh, what? This one doesn't adjust at all? Uh-oh. Why isn't this one adjusting? There we go. Yeah, so that doesn't achieve the same thing. So weird. Why is it like that? Why are you like this? Why are you like this? I think the way that I'd be able to achieve it is just leave this one alone, and then this is the one that goes from one thing to the other. Because like the capacitor maybe on the output of this? What if instead of putting the capacitor on the input, it's on... Oh no, but the capacitor, without the capacitor, it'll just not display the negatives. Like here, where's my one jumper? Where's my yumper? Yumper? There it is. All right, one jumper. And that's going to go, not here. Where's it going? It's going right here. Where's it going? Here. Okay, so Now, it's doing the same kind of thing where it's like offsetting in a weird way. Oh yeah, let me give it full ground on that pin. Oh, but I'm still giving it the... No. This is the 2.5 volt. See, that just saturates it. But then if I give that ground, we got the same performance. Did we get the same performance, though, or has it always been doing this weird thing? That's a good question. Is it really amplifying the way that I want it to, or is it just offsetting it in a weird way? There. So now that's like that, and... I mean, it doesn't seem to be... Why is the lower level coming up on us like that? It's doing weird stuff with the... oh, sorry, you guys didn't see that. This feels like it's offsetting it more than it is just turning it up and down. Whereas with the other one, it looks more like we're turning it up and down. Maybe I just need to suck it up and implement the Hajiwo circuit, because it's working a little bit differently. With the 50K pot on the MCP 6004, the ratio of that -10 offset, the reference being applied to -5 volts in order to pull it all the way down, is changing. That's what's going on. So it's the ratio between my comparison is changing, and that's why it's jumping around like this. So it's not really good for an adjustable gain. That's what's going on. I finally understand. There may be a more complicated way to do it. Like if I do variable gain inverting op amp voltage reference. All kinds of stuff going on here. Maybe I need to crack open one of my circuit books and start looking through. Adjustable range, huh? And they put the other one to ground. What's that going to do? What if I put the other lead of the 50K, or the 100K rather, our virtual 50K, to ground? Literally nothing. Literally no difference at all. Okay, cool. Thanks for participating. Jeez. That did nothing. You son of a bitch. Well, wait, the center lead has to go to the... It does. Yeah, the center lead goes to the negative, and the V out over here goes to the side lead. Yeah, it does. Okay, never mind. So that's perfectly implemented. It just doesn't do anything. It does nothing for my end-to-end. It's pretty saturated, though. It almost seems like that is the same thing. It's just when I add the capacitors and the offset voltages, like I need a negative offset on that, a negative 1.6. And I tried adding it in various places, but and if I wanted it to be positive, I would use a non-inverting, which is literally exactly what Hajiwo did. So without the -10 voltage ref, I could do this circuit, which is just this. But then that's 1 to 1. So it goes from 0 to 1 to 1 to 1. Or no, sorry, it's non-inverting, so it goes 1 to 2. This one has more dynamic range to amplify, but I can't get that voltage reference there. Unless I do something with a Zener diode. Oh wait, no, but it doesn't work the same when we do that. It does weird stuff. So instead of doing that, I think I have to add the second op amp in there, because that way we're not adjusting the ratio between these two. Instead, we're just offsetting this one. And actually this would be, so if I did 10Ks, okay, that's it. That's the solution. So instead of the 50K pot, I was going to redraw the whole thing. This is how it's got to be. I'm so sorry. So non-adjustable, because then the ratio between these three elements doesn't shift, right? So without that ratio shifting, I can then take these two make this one a 10K pot, and then this one just a 10K. And that way we would go from 0 to whatever, unless I need it to be, like, unless this one a 5K maybe here. Because what we have is 1 to 2. What's the relationship between R1 and R2? Hold on. What's the relationship there? There's more math to this than I'm giving it credit for. You're watching the machinations of a madman right now. I hope you appreciate this. I lost my mind for you, chat. So what we have here is, let's just do operational op-amp circuits. We got 10 fundamentals. There's a bunch of others. I mean, maybe I should look up the op-amp cookbook. Maybe that has got some good stuff in it. Basically, you could find all kinds of just very simple things that give you circuits and equations that run those circuits. So what we have, basic configurations, inverting, non-inverting, differential, transfer characteristics, closed loop linear amplifier. Actually, closed loop linear amplifier connected to closed loop mode with negative feedback applied from the output. V in goes in there, positive, and then R1 plus R2 over R2. I mean, the non-inverting amplifier is what we were looking at, and that's 1 plus. So V in to V out, it's just a transfer function. Let's go back to the other one. This one's simpler. What the circuit has is an adding op-amp circuit. So you take the voltage, the sum of the voltages based on the ratio of the resistors. And so you take this equation and you apply it to the summed elements. But the non-inverting actually has 1 plus R1 over R2. So you can't get below 1 with this one. So you can't desaturate it, which I'm wondering about. I think there's a circuit that I could just find that would do what I needed to do with this. That's kind of what I'm trying to get at here. Because it's like, you want to amplify it, but you want to keep it on the number line, on that offset line. So I don't know why. Oh, no, I know exactly why my circuit wasn't doing that. If we do that with the second op amp, then it should be. Let's wire this up, actually. Let's do this, and let's see if this fixes it. I've already got a 10K in there, so we'll be able to throw a couple amps that op. Opping amps. Oppingheimers. Let's implement this. So I got to rip up most of this circuit in order to make it happen. We'll turn output off. We can do this quickly enough, just at the like a last thing for the stream. Let me get you guys nice and close so you can see what I'm doing with the little bit of screen that I have that's in focus. And then let's take this out, and let me take the input off, and then I'm going to take my observation away here, and then we don't need this capacitor. We will be putting the capacitor in, though. And that's our final filter. And then this coming from here we don't need these. That's on the 10K already, but we're going to move that. Oh no, it's on the right one, it's just on the wrong pins. And then what values of components do we have in here? That's up to Hajiwo. Okay, so we do have a 10K and we have a 5K. So we're not going to need any more than just that. Where are my tweezers? They're there. So So here's the 10K that we need. Actually, these are all 10Ks. These two are also 10Ks. This one is, I think, the different one. And then our positive goes to either 1.6 or 0, and I think it's the only spot that needs that. Where did I draw this thing? So, yeah, 0 or 1.6 positive. Okay, and that would be, this is ground for the whole thing, and that would be the plus over here. Where's my weird easy jumper? I need to grab one from some part of the circuit. This is a good one. I can grab this. So from output minus plus, this one goes here. Output minus plus, there's already a 10K there. And then minus also gets a 10K. Where the hell did that one go? That's just gone. Jeez. The resistors are round and the tweezers tend to like, they pop out of the tweezers and go into lower earth orbit. Okay, so there's 10K and we're putting that through a capacitor. I'll make that flat. Oh boy. God damn it! There goes another 10K. Oh my god, it smells like grass clippings in here. I'm gonna die. My allergies are gonna kill me. I'm gonna die. Oh wait, but this one, this 10K comes from the other side of the board, which is nice and easy to do. I could just yumper it. Well, I guess I can pull it over this way. Oh my god, I'm gonna lose this resistor if I keep trying to grab it with the tweezers. So we'll just go here with the 10K. Here, let me pull you guys to the microscope so you can see what's happening. That's ground for that one. This does not need this anymore. And we can do a jumper directly over to ground. I will get a ground over here. And we'll go from here to ground reference. That's kind of sloppy, but it'll do. So now we're ground reference on this pin. This pin gets, oh, sorry, wait a minute. Yeah, ground, because this is the first amplifier, the summing amplifier. So this will be summing, and it will also have no gain. It'll be 33K. So we need to find a 33 kilo ohm resistor. We got one of them somewhere around here. That's a capacitor. Three. Well, it should be 3 more than that. Hold on, I'll measure it. Oh my god, the two-stroke motors have taken over. It's all I can hear. You guys might be able to hear it a little bit in the background, but sometimes it's hard to tell unless you're on headphones. I hope you guys aren't listening to me on headphones, because then that's a little bit intimate. This is a 25K. When you see a letter in the resistor, that means that it is a code, not a direct value. Another cap. Oh, it's prowling around. They prowl around when they get back here. I can't see that. I'm going to do this. Come on, give me a value. 25K. That's another 25K. We need 33. That's cap. Yeah, that's cap. Okay, so let's find 30. I think I have 33 in regular resistors. One sec. 33 in a regular resistor. Oh no, I have 39. I don't think I have 33. But didn't we do one of these designs earlier? Shouldn't I have one around? I thought I made a little... That's 330. 47. Oh no, 33K. Here we go. 33K, and this will be our feedback resistor. So for this one, I think what I want to do is, since it goes from minus to out, and those two pins are right next to each other, you just fold this downwards like that. And so now we have the resistor that can span two holes of the board. So two holes of the board, give it a little clippy-do. When we get close over here, all I need to do is dropping in this thing right between our, let's see, that's voltage right between our output and our negative feedback. So just like that. So now that is going to produce 0 to 3 volt signals. I should say 3 volt to 0, but then we're going to invert it back with an inverting amplifier that we can then scale the amplification without the ratio of the input and output changing. Brilliant! You guys are so smart. This is output. Input is right there. Or I can go this way. I mean, this doesn't need to be here. Input to the whole system right there. Let's take that. Let's go over here. Let's put a little kink in it. Everybody has their little kinks. Kink in it. And then we'll get this over to there. Just put it right there. Now I gotta take this over to here. And now I can change the reference from the 1, and it should work. So that goes from, that one's the positive lead. This one here, so I need to actually turn this one into a vertical resistor. I don't think I have the room for the leads. Well, that one's going to be a little bit hinky. It's going to be not going to work quite as well. Holy shit, I hate meetings. I think that's pretty much a uncontroversial opinion. Yeah, I guess I'll give this one a little lean. That one's going to have, this would be on the lean. So, what is it? No, that's the output. Wait a minute. It's output minus plus. Oh, no, but this is the ground lead, and then this is the, so output minus, okay, pin 1 is the output, got it. This one gets a 10K between, is that what this one is? Wait a minute. That one's input, no, it gets an input, and then 10K between, which is this. Okay, yeah, cool. All right, so I got it right. Input goes into the negative. Between output and negative, we have another 10K. And that'll do our scaling for us. And that'll be inverted. And then we've got a ground here that can become 2.5 volts. So if I do 2.5 volts initially, we'll just hit that right there. Sorry, 1.6 volts. And then on the input, instead of just getting input directly, we have a capacitor blocking DC. I could use this one. There's that other little tiny capacitor. Here we go. Okay, so there's the circuit that's in the picture. Let's give it a try. I said, let's give it a try. Let's give it, oh. Okay. Oh, not plugged into the output. Nothing's plugged into the output. So the output from the op amp, without the filter, I'll just go directly over. So this would be the output here. And we're going to here. Okay, that's fucked. It's all kinds of fucked. Doesn't do anything. Try the different capacitor. Nada. Okay, let's probe around and see what we got. Wait, what's this? What happened? Oh, well, that's amplifying on the offset. Hey, look at that. And when I get rid of the offset, whoa, and let's put this in there. I need to get like a switch that I can put on the breadboard. I got plenty of them. I got thousands of switches. Because of a couple bad orders. All it takes is a couple bad orders. Everybody loses their mind. That didn't do nothing. Oh, wrong pin. Give me this back. Let me find a proper jumper. I don't have any. Where did they all go? If I undid an entire circuit, why am I still missing? All right, so this one here goes to there. Breadboarding can be such a pain in the ass. Yeah, cool. Oh yeah, no offset here. So instead of that, I actually get this. Huh? What's going on here? So with that there, my input's coming from here. Did I mix up my in and out? Hold on. Oh, I put my input into the wrong pin maybe? No, that's not right. Now this is the input pin because we are on this side. So on this side, double check the schematic, or rather the pin, the data sheet. Yeah, input minus plus. Input minus plus. Plus is going to ground. That's correct. This one's also ground. Correct. Input minus between those two. I've got my resistor, and then input resistor minus. Yes, it's also there. That is correctly implemented. This thing, positive, because it's 3.3 volts, input minus plus. Plus goes to ground. Minus has a 33K from lead to lead here. That's hopefully making contact. And then the input has a 100 and a 200, which is 100, 100. So this one has a 100, jumps over, there's our input. This should work. It does not. Why doesn't it work? Is it the jankiness of my setup? It's usually the case. Usually it's the jankiness of the setup, because that offset looked like it was okay. Looked like it did something. Embrace the jank. Learn to live the jank. The jank will guide you. We've got our 12 volts. We've got our 3 volts. We've got our input. Double check that we've got input here. That is correct. Double check that we got nothing there. Starting to think this 33K is a lie. Filthy lie. What was that? Okay. Coming out of that other circuit. I have a positively offset 3 volts coming out that is inverted, but the offset is into the positives? Hold on a minute. I mean, that should still just invert it on the output here. Input, and then input to output over here through the potentiometer. I alter the potentiometer in either direction, I'm not getting anything. What the heck? It's not making good connection? Huh. Why do you forsake me? This is very irregular. Almost got something. Wait a minute. Is it the... Is this just janky? Is this what's going on? Something not connected properly? Let's go from the other side of the pot. No, it didn't do it. And then my output is definitely connected properly, right? Yeah. Definitely connected properly. Some element of this isn't quite functioning. Damn it. All right. Let's see here. Wouldn't be the fault of the filter. Ground isn't violated anywhere. This thing is plugged in properly. Our input looks perfectly fine. That wave generator is actually quite a good little piece of equipment there. God, I keep hearing little popping noises when I touch stuff. I know it's not shorting out. It's just the noise of stuff hitting itself. Little pieces of plastic. So 10K ohms on the feedback. I guess I could get more gain if I go over to the 100. Because I've got 10K in, and then maybe my 10K is 100. That might be the case, actually. Might be a totally different resistor. Did I measure it? I measured it. I measured it. I'm just getting nothing on the output. I fry my chip. Ground going to this pin going to ground, ground and ground. Not negative 12, ground. I mean, the 10K is kind of janky in here. Whoa, what's going on with that? Hold on. We'll check the value on this one. Actually, I'm going to get a 10K. Or no, yeah, 10K. 10K. That one is... I think that's a 10. I think that's the number 10. Then lead down, get a little cut. So, top pin is output. Between output and negative, I've got one potentiometer. Between input, that would be between input and output. This one needs to be between output and negative. So it actually needs to skip a pin. Was that the problem? No. No, it's not. No, it's not. Output of one going into the other. What the heck? Of course, that doesn't make me very confident. Input into there. Input into negative. 33K. Feedback into there. And then the output is coming from that pin. This is negative here. This one's plus. This goes to ground. This couldn't be more simple, and yet it's not working for some reason all of a sudden. It was working before, a little, but as soon as I got rid of the offset and the 2.5 volts, it stopped functioning. Did it get damaged? Well, drawing a little bit of current. The other thing would be, is it plugged into the output properly? I mean, by all means, I think it is. Well, that's something. So's that. Why is it offset like that, though? Well, okay, so we've got our power coming in, and it is no offset. It's centered around 0. And then this is shifting for some reason, but it should be connected to ground, so it shouldn't be offsetting like that. Let's see. We've got our negative 10 volts scaling going into it. So that's negative 10 volts off the charts. Scales it to 3.3. From negative 5 to positive 5, it's scaled to 3.3. So that's doing all that work already. I think I need to rethink how this thing is doing it. I think I need to rethink how this thing is implementing all of its various functions, including the offset. It's possible that I need to have that negative 10 volts be shifted by 1.65 in order to do this. I'm not totally sure about that. I need to have like a variable voltage regulator or something. Because we've already got a reference voltage going into this. I just don't get why I'm not getting an output right now. Input, feedback, through there becomes nothing. There it is going away. What the douche? That should be doing what? What the huh? That one goes to ground. There's my signal. And look, I'm scaling it with a potentiometer. But then when it comes to outputting, there's nothing. What the fuck? I mean, these holes don't appear to be gripping the wire at all. But I'm having a lot of trouble here today. I'm having a very bad time, suddenly. Why am I having a bad time? Input negative, output negative, positive. Positive, jumper, ground. Input, signal there. Signal here. Output. Nothing. And yet, this signal is scalable. It's like almost doing what I want it to. Sort of. In the grand scheme of things, this thing would be, oh, that's what it is. No, okay, so that's why it's not working. It's scaling it for 0 to 3.3 volts, and then I'm flipping it again. So although the signal is flipped here, it does not need that negative 10 scale to go into it. What it needs is for a voltage. It's essentially the Hajiwo circuit all over again. I wonder what Mutable Instrument's doing for stuff like this, or if they're doing anything, like setting up with an offset. I gotta look at more of these circuits then. That's what's gotta happen. Yeah, okay. So we went a little over time because my brain was racking about what these circuits are doing. The Mutable Instrument circuit is adding a negative 10 volt reference in order to shift the positive and negative 5 volts up to and then scale it to 3.3, right? So when we try to put it through an inverting amplifier, it is inverting it to a range that the MCP 6004 cannot use. It's inverting it into, and you know, the math works out in weird ways, and the signal mixing isn't quite as crystal clear as I'm putting it out to be. But what basically is happening is we're flipping it to a part of the number line that we can't use. We can't output. Strange. I would have to like offset and invert it or something like that, or do like a unity gain. No, that doesn't work. What the how in the fuck? Yeah, so essentially it would look like Hajiwo circuit again. It would just be a non-inverting amplifier with gain control. And I'd try to scale that to 10 K. Which I guess that's easy enough to do. It would be 10K and then another 10K to ground. So in the non-inverting schema, it would look like, hold on, let me find it. It would look like, where did those, there it is. Look like this, which we can do easy enough. R1 and R2 are going to be our 10Ks anyway. but then we can only go from 1 to 10K. We can't scale it down further, which is why that's why I wanted to use the inverting amplifier, because then it would go from fractions and up. But let's just implement this real quick. So that's just rearranging a couple things. So if I take our input, and our input goes directly to the plus line, so that's actually going to take a slightly different wiring deviation. Take this out. Our ground is still ground, but now this one goes to ground. So this goes to ground. This goes to the negative input. Actually, this one goes to the one I've left behind. Simple crush to occupy my time. Okay, so that one goes there, and then this one goes between output and there, and then input goes to positive. These are like popping out of the hole. I'm really annoyed about that. Stay there. Just stay there. Stop it. Why are you popping out? What the fuck? These things are like the least attached lines. What the hell? Stay there. Jeez. Okay, and then this goes to... I'll use a long lead just so we can get it done. This is the positive. So now... There we go. Except that's a little weird. That's a little strange. What's going on there? I guess it's scaling it between 1 and 2. Oh, but this is the 100K pot. Oh, and it's not making great contact. That's the other part. That's not what I wanted. Okay, well, that's what it is. So we're inverting, we're not inverting amplifying, but when we amplify, we reach saturation. And instead of amplifying on an offset number line, it is just simply punching it in spite of the positive and negative nature of what's going on. Because this has already been scaled for a full range 3.3 volts. It would be better to just put that directly into the input. And then when it saturates, and it's always in range. That would look like this. This is what the signal is supposed to look like. Like that. And that goes from... Well, right now we're at half of the voltage available to it. So if I turn this to a amplitude 10 with 0 offset, that's our full... It didn't do it. Amplitude 10 volts. There. So now we are a little bit saturated, aren't we? That's not going to affect it. Oh, and yet somehow it did. You can see here that we are at the full range of available voltage for this thing. So 3.3 volts, it goes all the way up to 3.3 volts, clips a little bit, and then this goes all the way down almost to 0. That's where it's supposed to be, and it's probably down to this resistor being a little bit funky. Yeah, see? If that was a slightly more accurate resistor, we would get the full range. In which case, like, all of the offsets and stuff should be better done digitally. But I think syncing is done digitally, so I'm going to have to figure out how I'm going to get this circuit to do what it needs to do. It might just be that I'll do exactly the Haji-Wo circuit and leave it at that, right? We just do exactly what his circuit does, and that way we get the same exact performance out of the thing. It just means that in order to do that offset and stuff, we'll have to actually flip switches, which, I mean, if you do like auto ranging on it, if your maximum input voltage is 3 volts to 0, it just means that if you're zooming in on stuff, you won't get as much fidelity, which is okay in this circuit. Well, I learned a lot. I hope you guys learned a lot. I'm throwing my hands up. I'm throwing everything on the desk up. Tomorrow, we're going to come back. I don't know if we're going to do circuits again. It depends on what I feel like I'm in the mood for on Friday. And usually I kind of like to solve a problem, but maybe we like take a break from this because it's been kind of a slog in the circuit realm. Thank you for the raids. We got CosmoQuest and Code Rush to raid, and then Commander Big M did a 6-month sub, which is pretty cool. Kind of a quiet Thursday. Gonna come back on Friday. We'll see what's going on. See if there's anything fun to work on. I really wanted to take a big bite out of all of this analog circuitry because I want to get Julian and Dave back in here. But we'll see. We'll see where the winds blow, right? And I will catch you guys later. Have a good one. Do we raid anybody? I haven't seen, like, I don't know. I mean, paleontologizing, I definitely want to get on that guy's radar. But is Uwo up yet? Uwo Slab? I don't think so. Why can't I expand this? There we go. Ella's doing My Summer Car. Paleontologizing is on if you guys are interested. Cassidoo is doing coding. You guys should check that out. The rest is just the normal spread of people doing their thing. I don't know when Uwo goes online. I know he does after work, so he's probably like eating dinner and stuff right now. But yeah, I'll have to figure out what I can collab on him with. We got to figure out something cool. I will catch you guys later. In the meantime, you can catch me on Discord. You can kind of catch me on Twitter. I barely use it, but there's always some cool stuff going on, and you know, you can watch nerds debate each other on the Discord. Until then, I will catch you guys on Friday. Thank you for joining me for this. I learned something. I hope you learned something. We'll see if we can rectify that in the future. If you didn't, bye.